And I think everybody is seated, so we're going to start the recording. And then we can go on, and we're good. So, hi everyone. This is a Jupyter and IPython tutorial at PyCon. You have some install instruction. I will get back to this slide. I'm Matthias. I've been part of the Jupyter team since about 2012. If you want to see my email, you clone one of our repository and you git log. And as a day jobs, I'm at the University of California, Merced. Denis will not be here today. He couldn't make it, so I'm going to try to fill in for him as much as I can. But we have another Jupyter core dev in the back here, Paul, who is waving to you. Say hi to Paul. Hi, Paul. So he will be going through, helping you if you have any issues, and maybe at some point he will come in front of the camera, but it's not his job, so it's just helping today. You should have received these instructions. We're going to make sure that everything is slow in the first 15 minutes. If you have everything installed and you go to terminal and do JupyterLab, you should have JupyterLab popping up. If it's not okay, raise your hand or put a red sticky note on your laptop. And we're going to come help you make sure everything is installed so that we can move forward. If everything is good, you put a green or a blue sticky note so that I can have a quick overview of for whom it's going well and for who it's not going well. So you see, those people are nice, and they put a sticky note up so that I can see that it's mostly doing fine. I'm going to do a short presentation for you to finish installation. Some of you I know just started to download. And then we can directly dive into Jupyter. And if you're stuck, if you can't installing on your machine, just don't stay quiet. We have a way to set you up online. We don't have hundreds of machines, but we have a couple of machines where you can play online if it doesn't work on your laptop. So what is Jupyter? Well, depends who you talk to. But mostly when people talk about Jupyter and IPython for some old-timers like me, it's mostly known for what they call the notebook. We're going to more detail what is the notebook later. It's usually it's a web server and a web app that can contain code, narrative, math, and results. You probably all have seen Jupyter maybe once before. Who has never seen Jupyter before? Okay, good. So nobody raised their hand. And usually these things is attached to a kernel doing computation. And here we're going to use Python. If we dive more into what Jupyter is, it's a set of standards and protocols. We have the notebook document format, which is usually a file that ends in ipynb, which is JSON inside. It's relatively easy to manipulate. It's a ZMQ protocol. So why ZMQ? ZMQ is a library which is available in many languages that allows the front end you interact with to talk with the process that does computation. And the kernel can be local or remote, and the front end can interact with the users, but sometimes not. And we have the default implementation. The default implementation is the one you usually know about. It means that we have many languages that are maintained by the community. You can run Scala, you can run Haskell, you can run Julia, Erlang, Ruby, whatever. But because Jupyter is written in Python, we're going to focus on IPython, which is one implementation that implements the Python language as one of the kernels that can run in Jupyter. But you can use Jupyter only with R if you wish to. And there are many front ends. You can see that you can hook Jupyter with VS Code, with Interact, with Atom, with a normal notebook. And we're going to mostly focus on one front end today that you may have heard. It's called JupyterLab. We are going to do everything using Python 3. I remind some of you that Python 2 end of life is supposed to be January 1st of next year. You can still use Python 2 after that, but the support is going to decrease really fast. It has already started to decrease really fast. There is no problem if you want to use Python 2. You can still use Python 2 with Jupyter, with older version of the kernel. If you have any questions, you can come talk to me later. I'm going to do a quick FAQ, and at the end of the FAQ, or even if you have questions now, feel free to raise your hand, and I want to answer your question now, so that you can be on peace of mind and focus on the tutorial after. How do I pay for hosted Jupyter? This is non-exhaustive, but you can Google, and there are many companies that pay for hosted Jupyter online. So if you want to have a big server with thousands of machines, Probably don't want to talk to the Jupyter team, who are mostly volunteers in open source. Some of us know and can redirect you to how to pay for hosted. But you can find a lot of companies doing that online. How do I run Jupyter at scale? If you came here to know how to deploy Jupyter for your lab, we're not going to, or your company, we're not going to talk about that too much. You want to Google about Jupyter Hub. As soon as you have more than one user, you probably want to run Jupyter Hub. Jupyter Hub is one way of dispatching users to their own servers and do things at scale on Kubernetes, if you know what Kubernetes is, or on raw hardware if you want to use raw hardware. Those are two links. All of that will be online, don't worry, that tell you how to deploy Jupyter Hub. So that one is the core documentation, but if you want to just do things to copy and paste and get a server for 20 people, that would be this one. After that, there's a lot of customization possible. How do I share static notebook? You will do notebooks. You might want to have some of your colleagues or friends to view those notebooks when they don't have Jupyter installed. For that, you might want to use nbviewer at nbviewer.org. What happens is you give it a URL to a public notebook. We don't do integration. We don't do authentication. So as long as a notebook, a JSON file is public, you pass the URL here, and it will convert it to HTML on the fly for the person. It's static, so it means that they can't interact with it. It's automatically updated. It looks at the latest Git. Usually this work with, it doesn't work only with GitHub, but it's mostly work with GitHub. It look at whether the commit hash has changed, and if the commit hash has changed, it will re-render. It means that you just have to push on GitHub, and the notebook will be refreshed. So it's a nice way of sharing it. And we just got one new Jupyter developer that arrived in the back, Matt from Netflix. Say hi, Matt. Thank you for being here that early today. So Matt is working on mostly the things that powers nbviewer in the back, nbconvert and papermill. That is a nice project from Netflix. If you want to share live notebooks, like you want someone to interact, you have data sets that you've explored, but there are thousands of images, and you don't want to print a 1,000-page report for your boss or your colleague. Or you have a paper that you've published and you only show some data sets in your supplementary, but you want people to interact with the other data sets. You want to go to mybinder.org. Slightly more complicated than nbviewer. It doesn't take a single notebook. It tells the full GitHub repository. And what it does, it will try to analyze the dependency. If you do the right file, it will create for you on the fly a Docker image in the cloud, which is there for 2 hours, and you will be able to interact with that. So if you have some notebook and you want people to be able to see how some parameters change, how the plot look like, or which data set to look, you might want to look at mymatter.org. It's hosted so far by the Jupyter project from UC Berkeley. So there are some limitations on how much compute you can do. So please don't mind Bitcoin. If some of you don't manage to install the tutorial material, you can use Binder to try the tutorial, or if you're on YouTube, or whatever video system is being used to record me right now. Which language are supported? We said that there is only Python that we're going to see today. There is a wiki if you develop your own kernel for your own language, because some people like to invent languages. You can go there and add your own kernel. It's mostly community maintained. You go on the Jupyter wiki and you look at Fortran, where is the documentation for Fortran, and you can install the Fortran kernel. One of the questions that we often have, starting to get better, is what is the difference between Jupyter Notebook and JupyterLab? We're mostly going to talk about JupyterLab today. JupyterLab is a new front end that we rewrote from scratch starting 2 or 3 years ago, because we were Python developers and we started to write JavaScript for the main notebook. And so the main notebook still exists, can still run. Usually when you use a main notebook, you can only have one notebook on the page. And JupyterLab is better software engineering. You can have several notebooks on the page. You can have text editor. You can have a terminal. Why do you want to use one or the other? It's more like Vim versus Emacs, so left of the room versus right of the room. GIF versus GIF. It doesn't really matter. You can work with each other. You should be friends. They read exactly the same file format. So if you have a file in JupyterLab, it will work in Classic Notebook. If you have a file in Classic Notebook, it will work with JupyterLab. They can connect to the same kernel. There is only some extensions that exist for one and not the other. And the Classic Notebook that you may have seen when you do Jupyter Notebook on the terminal will probably go away someday. So it's slowly being sunset. And JupyterLab should be in version 1.0 relatively soon. We're going to use something which is slightly before 1.0. So if you see bugs or things that annoy you, you can still give us feedback. Say this doesn't make sense. It would be nice to change it before 1.0. How do you get help once you are out of the tutorial? I would suggest you go to jupyter.org/community. There are a lot of channels, and I would suggest for you to join the discourse. You can log in with GitHub or with Google if you deactivate AdBlock, because AdBlock tend to remove the things that tells you can log in with Git or GitHub or GitLab or any other provider. And of course, if you're in the room here, you put your red sticky note or you raise your hand, and we're going to help you. And so that's the slide about the sticky notes. I already told you a bit how it works. So when everything is good, when you think I can go faster, you put a green sticky note, and don't forget to put a task to remind you to remove your sticky note. Otherwise, people forget they have the green sticky note. I think everything is fine, and I just go faster and faster and faster, and you will get lost. And as soon as something is wrong, you put a red sticky note up, and some of the helpers will come and try to help you to install, or I will stop and ask questions. You can think that as a try except in your brain, and as soon as there is an exception, you put the red sticky note, and I will slow down. Do you have any questions so far? Does everybody has everything installed? Feel free to interrupt me during the tutorial, ask me to rephrase if I question or if I forget to do something. I know I can have a really strong French accent sometimes. So if you don't understand, it's because of me. And so again, the install instructions are here. PyCon 2019 branch, it should be the default one, so you shouldn't have to do anything, but just in case I've put it here. And once everyone is ready, we can go to the tutorial. So I don't see any red stickies. So we have about 1 hour before getting food. Okay. Is that big enough for people in the back? No, it's not big enough for people in the back. They all want something bigger. More? Okay. Yeah, well, they want me to. So some people want me to change PS1, so what is written before, and others want me to change my OS. Yeah, I would prefer to change my keyboard, who's starting to have keys that type 2 times and keys that don't type. You probably have heard of that. So I'm going to do a lot of typo. It's definitively not because I'm not awake, it's because of my keyboard. So here we are in where you should have probably gotten your material from GitHub. You see here that I'm on the PyCon 2019 branch because I have my terminal set up this way. And you see that nothing has changed because I have the green check mark. You might not have that. And so the first thing we want to do, and not forget to do that, is conda activate PyCon 2019 to be in the environment I should have had you create. And so now I'm in PyCon 2019, and I don't have much space. But we're just going to start with one thing, which is to press Jupyter, then a space, and lab. If you have any questions, you can do --help, or it's a normal command line. You can run things. And once you do that, it should hopefully start JupyterLab, which is kind of like Jupyter Notebook, and open your web browser at a specific URL. One thing I would suggest you do later after the tutorial, if you want to use it on your machine, is to look at the documentation on how to set up a password. Because like this is running a server on your machine. Normally people cannot access it from the outside, but other processes on your machine may try to access Jupyter unless you set a password. There is an automatic token that is set up and so on and so forth, so this should be secure, but better safe than sorry. Look online, look on how to set up a password with Jupyter, and now you should be prompted by a password the first time you log in. So here we will have the JupyterLab interface. We're going to see exactly what is a JupyterLab interface and how it works later in the tutorial. We're just going to focus on some of the Python first, because playing with buttons is not too interesting at the beginning of a tutorial. You can see that there is a bug already here. That's weird. There is no icon here. I don't know why. Let me try to force refresh. Okay, so that needs to be filled somewhere and figure out why. Probably because I'm zoomed in. So here you have a file browser that you can expand and collapse using this if you want to have more space in your screen. You'll see that I have relatively few real estate on my screen, so I will do things slightly different than you, but you should be able to have more space and see more clearly what is happening. You see that you have a menu at the top. Here I'm full screen, so I remove the, actually in a web browser. So some of your shortcuts you might be used to, like go to the next tab or previous tab, might be slightly different. So if you're confused of what's happening when you are a big keyboard user, that's because you have two levels of interaction. You have the interaction with your browser windows and the interaction with JupyterLab. And so what we're going to do is, well, first look at that. You will see that we always have first the notebook, the folders and directories of where you are. Then we have this small orange icon that are notebooks, and then we have other kinds of files. And so when we sort by name or by last modify, you see that it's actually three groups. You have the folders on top, you have the notebooks after, and you have the other files after. So don't be confused if you think, well, no, it's not sorted by name. It's because the folders themselves are sorted by name or by last modified, and etc. and so on and so forth. And we're going to just start with going with notebook number 1 and double click on it, and it should open a new panel like that. And now I'm going to collapse that just to have a bigger real estate. And now we're going to directly interact with our notebook using the JupyterLab interface, which is quite similar to the normal notebook interface with some differences if you use normal notebook or if you want to use normal notebook after. You'll see that we have many cells. So it's sometimes hard to figure out where the cells are. You can see that you have the indicator here of which cells I'm currently selecting, which is this blue line. And you can see that I can move it up and down with my keyboard when it works, or click with the mouse. And you will see that usually we have a modal interface, which means that you can either be in a mode where you are going to manipulate cells themselves in a notebook. So a cell is a chunk of text or code. Or you can be in a mode, if I press enter, where I edit the cell. So that might be one of the tricky things where you might get lost, is that if you are in a mode where you are manipulating cells themselves and try to type, it won't edit the cell, it won't write things in the cells. It will basically just do things with the cell. Like for example, if I press D twice, it will delete the cell. So that's something to keep in mind. But usually the keyboard shortcut you will use most of the time is Shift-Enter. So you press Shift and you press Enter. And what it will do, it will execute or render the current cell. So if it's some markdown, it will just display it. If it's some code, it will send it to the kernel, execute the things, and show the result back. So usually when you want to go through a notebook, you press Shift-Enter many times to go down. Some useful things when you're prototyping. There is also Alt-Enter that execute and insert a cell below. If you have some long code and you want to add some debug statements. And Control-Enter to just rerun the same thing again and again and again and again. So you don't have to do Shift-Enter up, Shift-Enter up. So we'll see that, but first let's do some Python first. So here you have the first cell that says print hi. I'm going to assume all of you know what that does in Python. And if I print Shift-Enter, it will just say hi. And now I can go up and modify my code, everyone, and press Shift-Enter, and it says hi everyone. And you see that I have this number in front here. In normal notebook, you would see int2, and that means that it's the second statement I have executed in my current session, because the document I'm editing and the process that is running in the back are different. I can restart the process without having to destroy my document. And so now we're going to that normal Python, but IPython itself, because we have IPython in the back, who is just executing Python, can do more things than pure Python can do. And we are mostly targeted toward having interactive stuff and making you interactive data analysis more efficient. And so the first thing you should be really happy about is a question mark operator that allow you to get help on a large number of things, and we try to pull more help information than what pure Python does with a help function. And so if you just want global help because you're lost and you don't know how to do things, question mark will give you a quick summary of what you can do in IPython. So this is question mark itself, and introduction overview of IPython features. If you want some information about an object, any object, you can use object question mark and then shift enter, or question mark object and then shift enter. If you want more detailed information, you can use two question mark. We'll do that later. You also have present quick ref, and you can also call IPython a pure Python help system. This is quite long, so I'm not going to do that now, and I'm going to just collapse this cell by pressing the blue button here on the side, it just be green. We'll see more about the interface about JupyterLab later. And so now we're going to see how to get help on objects. We're going to look at the collection module. We are going to import it and look at collection name tuple, question mark. Name tuple is a nice, really nice thing. It's like a tuple, except you can give name to each of the elements. And you see that we're going to pull the signature from the Python documentation. So it gives you the positional arguments, the keywords arguments. So this means that the star here means that those arguments are keyword arguments only. Then it pulls a docstring. It tries to find where this file is defined. So you know that if you have different versions of NumPy installed or different versions of Python installed, you can figure out that it's the right one. And that it's a function. Let's collapse that as well, but you don't have to. And if you want more information, well, you're going to put two question mark. And what you should get is not only everything you got before, but you should get the full source. So if you ever wonder how a function was defined, instead of going through the library, the source of the library, and searching through it, you can actually directly see how it has been written, which is really useful when you do science. You want to figure out how things are done to understand correctly if there is a bug or not. It does some other fancy stuff. It will try to find if there are subclasses at the bottom. Here there is no subclasses. So if you want something more specific, in something like Matplotlib, it will say, well, here you have an artist, but you also have an artist which you have the circle artist, or you have the ellipse artist, or you have the square artist, and so you can drill down into more specific things. Another useful things, let me re-scroll up, sorry, is you know that there is some function somewhere where have that name somewhere in it, but you don't exactly remember how it's called. You can use wildcard with the question mark, and it will try to recurse your namespace and find something that matches this pattern. So I know that there is something I want to use that have int in it, where I have the ability to get either a floating point error, or is it breakpoint, or is it int, or is it print. So then you can search in things when you don't really remember what you want to use, because you only use it once in a while. There is also the quick reference that is slightly more compact than what we've seen before with just question mark. So it will tell you, well, yeah, you can search for everything that have ABC in the full namespace. You will have many of IPython specific syntax that starts a line with a single % or 2%. We'll see that later. And you have a number of reminders of things you can do. We'll go through all of that in this notebook. As any other IDE, we provide tab completion. So if you have some code and you want to figure out what you can write after, you can press tab. As Fernando Perez, the creator of IPython, said, we weaponize the tab key. The tab key does a lot of things. So we've imported the collection module. We can press tab, and it will tell you what you can complete with that. This is a really nice example because here you see that only ABC has an M in front. I'm going to just dismiss that and repress it. It had time to compute more information, and now it shows me more information. And it shows me that I can complete to ABC, to chain map, to default DQ, etc. And it gives me the type of each of those things. So unlike many IDE completers, this is not statically inferred. This is actually inspecting live objects, which means that if you have an API that returns a different kind of object, once the object has been is in the namespace, you can tab complete on that, and it will also tab complete everything that you have defined. So here, let's say I want to look at DQ. I can go down to DQ and press enter to get that. And now we're going to see the second thing that tab can be used for. I'm going to open parentheses, and I'm going to press shift tab instead of tab, and it's going to give me a quick help. So if you don't remember the signature of a function, you can press shift tab, and it will show you approximately the same thing that question mark will show you. You'll see that it's slightly different in classic notebook, but here you see that collection DQ takes, so the signature is not really useful now, but the docstring is. It takes an iterable and then a max length, and it returns to you a DQ object. So now I can actually do 1, 2, 3, and a max length of 5, for example. We're not going to look into what DQ is, and then I press shift enter, and now I have my objects here. Not going to DQ itself, but just trying to go through things you can do. A lot of things that you do interactively, you might forget to assign a variable. So now we're going to see how you can use some IPython features to get back some result you forgot to assign, especially if there are large computation. So we're just going to do a dummy computation. We added the 2 and 10. We could have done that using TensorFlow, but it might have been a bit overkill. Well, if you want to do that, you can see FizzBuzz in TensorFlow, which is a nice one, an article online by Joel Gruz. And now we want to basically add 10 to that. But TensorFlow basically computed for 5 hours on our GPU, and we don't want to rerun that. So you can use a single underscore. If you haven't assigned to single underscore, it's automatically there in your namespace and refer to the previous result. So now, hopefully, the previous result is 12. If I add 10, it's going to be 22. We also have, we'll see later, we have double underscore, which is 2 results before, and triple underscore, which is 3 results before. And they shift all along, so it might be sometimes hard to follow. You saw here that, well, you wrote something and it was automatically displayed in the interactive shell. If you have a big result, like a pandas data frame or a matplotlib figure or something, you might want to not display it. So one of the specific IPython syntax is if you end your line with semicolon, it will suppress the output. So here 10 plus 20 is 30, but is not displayed. And now if we look at the previous result, because we didn't display it, that's one of the things we need to remember, is it still refers to the previous one that was displayed. So because this one was none, actually, it skipped and still referred to this one. So it might be useful if you want to do some temporary computation and just refer to what you have back. One of the issues with underscore, double underscore, and triple underscore is that they keep shifting around. You don't know which ones they are. So what you can do is actually refer either to underscore and the number of the output. So 10 would be this one, or directly refer to out with an uppercase O and the number you want in it. And so hopefully underscore 10 should be equal to out 10 and should be equal to 22. So they're both equal, and we are going to check the value of 10. It's actually 22, so that's good. So when you have a lot of things that you've done and you want to reuse, you can refer to it. One of the drawbacks of that, especially if you're working with really large data sets, is that some outputs will stay in memory, where in normal Python they will be garbage collected. So be careful, you might use way more memory when you use IPython than when you use normal Python. And we have a question here.
Semicolon appended, that computation, it was still done, right? It's just not displayed.
So, well, this computation, yes, this computation was done but not displayed. So that's a good question. Well, we can try. I'm going to talk a bit about the JupyterLab interface while I'm here. I'm going to not edit. I'm in an edit mode here. I'm inside the cell. I'm going to press escape, so I'm modifying the notebook itself. I'm going to press A for above to create a new cell. I'm going to define a function that prints, let's do double quotes, I'm called, and return a result. It's really difficult. So now I'm going to call f and put a semicolon. And so we are going to check that the function is actually called, but the result it returned was not displayed. So it's called, but the result is not displayed. If I remove the semicolon, it's called, but I have a result. You see here that there is a slight difference between printing and returning the value. You see that the value which is printed doesn't have a prompt in front of it. So you can't refer to something that has been printed. But you can refer to the value of the last statement of a cell, so a result. So let's do this example. Let's go create a new cell. Let's do 1, 2, 3. So we have 3 statements. Only the last statement would be printed, which will be 3. We can check that 18 is actually only 3. And 1 and 2 were executed, but the results were not outputted. If we print them, it's the same. We can print 1, print 2, and you see here that we have 1 and 2, but they don't have a prompt number in front. Good question. If you want to access what you've written before, you can also do that with in instead of out. So you saw that on input 11, I got 10 plus 20 that I surpassed output. You can also use things with I, etc. Or if you want to have more information about everything you wrote, especially since you can edit what has been previously done in the notebook, you might want to re-see exactly the command of sequence you have. You can use the %history magic. We'll see what the magic is later. With line 1 to 5. So here I would see only the first five inputs I've done. And you see that the first five items I've done was to print hi to everyone. I edited the first cell, used question mark, worked with import collection and collection name tuples, and then did collection counter to question mark. And now we're going to do a small exercise. I'm going to let you look at history question mark to see what the documentation of history is and try to see if you can extract the last 10 lines of history to a file namelog.py. And we have a question here.
So are in number 23, the 1 to 5, is that referencing the numbers to the left?
So the question is, in history 1 to 5, what are 1 to 5 referring to? Are they referring to the number on the left here? Yes, they're referring to the in number. But that's something that should be hopefully documented when you do %history question mark. It should give you more information. And some of the information you will see is that this is not related to only the notebook, it's related to IPython itself. And you can refer to either this session, the current session you're in, or you can also refer to previous session. If I remember correctly, if I do that, that's going to be what I showed earlier today to Mike. I showed him how to do some of the auto-await stuff, and you see that it's my 383rd IPython session, and that the 5th line of the 383rd session was auto-awaited true. And here I used tilde to do the previous session, but all of this syntax should be defined in history question mark, where you will get some information. So let's take 2 or 3 minutes to make sure that you're fine with all of that. If everything is good or bad, you can put your green sticky note and red sticky notes. You can ask questions. Okay, so I didn't remember everything correctly, so the n was just printing line number. It was not referring to the actual range. The actual range is its own parameter. And so if I do history question mark and put a % in front, so I have the information. So it gives me some examples. It tells me what n print line number for each input. I also want to have the f file name, so I'm going to do -f log.py, and I only want to see get the last n line from all sessions. So if you ask for only one session, that should be that. And so if I do yes.
So how do you, since the -l is the last n lines from all sessions, is there another option that makes it say just the current session?
So if you don't give any, like the session are the things before the slash is here. I think the documentation might be slightly unclear here. So here you're asking for sessions 8 to 6. Well, 6 back and 8 back. If you don't give anything, it will only assume it's one session. Like if I did -l with -8 - -6, it would give me the last L lines of all the session -8 to -6.
Okay, thank you.
So if you don't put any session, it will assume it's only the current one. If it's unclear, you can send a pull request if you think you can write it better. I already did that. File.log exist, overwrite, yes. Overwriting file. And now we're going to see, well, that's nice because we can do that just after. We can see that IPython have some nice integration when you can call the underlying shell. If you don't know how to do things in Python, you can do it in bash. You just prepend your line with a bang, and then you write some bash. And now it will run bash for you in the back and give you the result. So you can see here that I have created a file called log.py that have the last 10 items of the history of my current session. Okay. And that's just what we had with perfect transition. You can, in IPython, access the underlying operating system using the bang and bang bang operators. When IPython figures out there are invalid Python syntax, it will automatically try to do all the right things for you. So if I want to see in which directory I am, I can do pwd and it will print it. And we have also one other special casing, which is equaled followed by some spaces or none and bang. And so if you do that, it will attempt to run the command here and get the output of it into an object that you can assign. So basically, if you don't know that in Python you want to do os.listdir, because it's something that you would take like 10 minutes to Google, you can just do bang and use your bash. If you're on Windows, I believe it uses the underlying command shell, I'm unsure, or PowerShell if you started with PowerShell. So this specific syntax is the syntax of the underlying shell.
So I assume it's just using standard in, standard out?
So the question was, I assume it's using standard in and standard out and standard error. Yes, it does. We're not going to do exactly into the detail of what this object is. It's not purely a string, it's a wrapper around strings where you can ask for each line independently or the full bytes or something like that. So if you want to play with that, once you've run these cells, I would let you play with it and do files ? And files.tab to see what's in it. And so here I want to look at everything which is in my notebooks folder. Well, let me just change that to ls to see what are the current working directory. You see that I have a notebooks folder. Or I can pass option to ls if I want it to be more complete and be as a list. You can do that. So it's pure bash if you know bash. And so now you see that you have those files in the current working directory. So now if you want to loop through those files, it will work. So that's relatively useful if you want to manipulate things. I like to match Python and bash. Like you want to copy only the ipynb file or only some py file. If I want to get only my py file, I would do star.py, and I would get only my py file. So let me remove that. Let me rerun that. And so now we basically got something from bash and got it into Python relatively easily using the bang. We might want to do the opposite. You might want to take a Python variable and send it to a bash command. And so when you run a bash command with a shell command with a bang, when you know that bash shell variables are usually starting with dollars like that, if IPython finds that some of that is actually in your current namespace, it will actually replace that by the value of files. So if I do that, it should basically use bash to echo the value of the list as a string. So the value of a file as a string here is not super useful, but what you can do is you can actually do some extra Python syntax inside here by using curly brackets. So it's curly bracket or $, not both. And you can see that you can, for example, get the file name, the first file name, data.ipynb as uppercase. And what you can do with that is actually put it inside some Python syntax, some Python loops, for example. And so here, if I want to see, I want to number my file and remove the extensions. What I could do is just loop through my file, and if it's end with ipynb, I will print a 2-digit number, a dash, and the file name, and otherwise put 2 dashes. So that's not extremely useful, but what you could do here is, for example, do SSH or SCP or any other manipulation of file system that you know how to do that, or submit a job in Slurm if you're using HPC or something like that directly from within Python. So you can use the flexibility of the command line and the power of the Python analysis tool. Question?
Is that flexibility where the curly braces were used in Python also present in other kernels, or is that kind of unique?
So are those capabilities present in non-Python kernels? It depends. They are implemented in the Python kernel, and it's a Python-specific features. Some other kernels have mimicked this feature. It's not Jupyter-specific, it's IPython-specific. If you use something, I believe the Scala kernel have some of that. The exact syntax might varies. And one of the reasons is that we use syntax which is non-valid Python syntax, so that we can escape that and say, oh, that's actually not Python, but we know how to handle that. In other languages, that wouldn't be invalid syntax, and so the kernel cannot have exactly the same syntax. They might want to use a different escape characters. Like instead of %, they will use hash, or they will use @. Small story before that. Before I joined the project, instead of using % something that you've seen with history, it used to be an @ symbol. And this was before Python had decorators. So if you've used Python decorators used to have @, and so in 2005 or 6, I believe, it was way before my time, you used to do @history instead of %history. And there are some things like you will realize that that kind of syntax is really close to what you have with fstring in recent Python, but this predates fstring. So we might have some conflict with newer Python features, and when this is the case, we will prefer to tilt toward having the Python way than our own way. So some features, if they conflict with Python, will slightly change. So that brings us to magic functions. So usually you have things that you want to do that are beyond Python. For example, you want to embed SQL, or you want to automatically time some code to figure out if it's fast or not. And IPython has this % that allow you to escape from Python and do some things. You will find two kind of magics, and you see that they have more a bash-like syntax. You will have one with a single % in front. When you have a single % in front, it means that they work only on everything which follows a line. So this % magic would, well, do the thing it does only on the rest of the line, which here is nothing, it takes no argument. And you will see also things with 2%, and when it's 2%, it acts on the rest of the cell. Here it's in a notebook. If it's not in a notebook, there are some rules to which scope it applies. And so, but basically this is most of the magic take strings, so they will take the value of that as a string and do any manipulations they want. Most of them only accept Python syntax, but you don't have to. You can use non-Python syntax. And so that allows you to basically escape from the Python to the Python syntax to do a lot of things. So if you just do %magic, it will give you a nice explanation of what it does, how it works, some of the possibilities. And we're going to go through some of them. So let me just go back to the top and just compact that. So one of the first one we are going to see is time it. And so time it is really nice when you want to get precise measurement of how long a block of code does. So Python has a time it module, but it's relatively heavy to use. We've done some opinionated default things. So if you say, I want to time this piece of code and see how much it runs, time it will run it a couple of times in a tight loop to see how long this specific piece of code runs. And you see that doing this takes 10.7 microseconds plus or minus 40.9 nanoseconds per loop, mean plus standard deviation. And we actually did 7 runs with 100,000 loops each. Because this is really, really fast, TimeIt did some experiments and decided, well, if I want to be able to measure precisely that, I need to run these things at least 100,000 times, because there is an overhead of starting the computation and stopping the computation. So it's going to run that, measure the time, and divide by 100,000 to get the 10.7 microseconds. And to get the standard deviation, it did the experiment 7 times. So that's what gives you the standard deviation. So now you have some confidence of how things are working. And if you have big block of code which is not a single function, what you can do is put 2% and it will run all of that. This has a slightly different syntax that if you need to do some setup only once, you can put the setup code just on the line and it will run the setup code on the line only once and then run that. And so now if I want to see how much that is taking, I can do so shift enter again. And now I have my %timeit, which is running this piece of code a number of times. And you see that hopefully counting to 110 is faster than counting to 1,000. If you want to test a function on a wide range of parameters to see how the behavior here is, if it's n squared or n cubed, or even worse, if it's exponential, what you can do is you can actually use the line magic inside Python syntax. And so IPython will be able to convert that into proper Python code and run the test for this specific size. And so you see that it's currently running for size 100. It should run for 200, and etc., etc. I would suggest for you to look at the %timeit help with a question mark. You will see that there is an option that allows you to not only print the result, but return them as an option, like as an object. And this object has all the information about the code you ran. And so now if you want to make a graph of how long it takes, depending on how, which parameters you gave, you can do that. So let's do that as an exercise. Let's do a question?
Yeah, your time is a little more verbose than what I have. Is there a reason that is? I don't have the standard deviation.
So you don't have, the question is, your timeit doesn't have the standard deviation. I don't know why. What operating system or Python installation are you using?
3.6 Windows.
So Windows, okay, so I don't know why. I know there are some codes to be careful that the plus or minus Unicode can show. It might be that. So we can try to take some time at the break to see that. And another question here.
Is there any way to cancel or stop something which is running in a cell?
Is there any way to stop or something which is running in a cell? Yes, there is. That would be the equivalent of Control-C. So let me do import. It will work only in Python code. Like if it's in C code and the C code doesn't have an interrupt handler, it won't be able to stop it. Import sleep. From time import sleep. And let me sleep for 15 seconds. And what I'm going to do is press I twice for interrupt. Once might be a mistake, so we have to press it twice. And so that will send the Control-C to the kernel, and it will interrupt. And so the way to, I think I'm slightly slower than my other plan, so I'm going to skip that. And so same thing, like we've seen that single bank can allow you to do bash on one line. If you do %% bash, you can write multi-line bash in the middle of your script. So that's kind of already some cross-language integration. If you need to drop a file on disk to do something specific and you want it to be in the notebook, you can use write file. So write file here will write a file called text.txt with this content. So you can write, I need to speed up because food is in 20 minutes. And you can see that I now have this file on just here. If you want to see all the magic that you have at your disposition, you can use ls magic. And you can see, well, you can start to see one nice feature here in Jupyter and IPython is that objects don't always have to be text. They can actually be rich representation. So here we have an HTML thing. And you can see that we have automagic, autocall, alias magic, page, pprint, xmode. We're not going to go through all of those because it would take us forever. You can see that we have alias, we have aliased couple of things so that you have consistency between Windows and Unix. And you have a couple of things that work on multi-line. So you have LaTeX magic, you have HTML, Markdown, we have profile run that we're going to see, we have timeit that we just saw, write file that we just saw, and if you want to run something, for example, on a Python 2 subshell, you might be able to do that. It's not sharing namespace, but it might be useful if you have some specific software which is Python 2 only. And so let's collab that and feel free to look at that. So the other thing we can look at, if you're writing some scientific code, you might want to optimize your code, and to do that, it might be nice to run a profiler. Running a profiler is often relatively hard. So I have this function that's just some computation, and what I can do is I can time it, and I see that it takes 332 milliseconds. Using timeit. You see that timeit decided to run the loop only once each because the function was already slow. And what you can do is run prun to optimize. So that's shipped in with IPython, and it will tell you, well, here is the breakdown of which functions, if it's something way bigger, which function took how much time. In this specific case, it's not really useful because we only have one function. But what you can do is you can actually ask some packages to inject some magic into the namespace. So not everything has to be built in IPython. As soon as you install a package, like when you follow the instruction, you install RPy2, RPy2 install the magic. You install line profiler in the instructions, line profiler provides the magic as well. And so what you can say is, well, IPython look for magics that are available in the line profiler package. And so if I tried, before doing that, to do lprun, it will say, well, I don't know what lprun is. Sorry, I need to do a % first. Say, no, I don't know what that is. Well, what I can do is say, well, load magic from this line profiler package. And now you have lprun, which is available. So how do you know that lprun is available? You have to look at the package documentation. And now what you can ask lprun is to run this specific function or functions and track the performance of this one. So that means run the line profiler, so line profiler run, track the function to optimize, and well, here I'm running the same function, but I might have some other code that runs that, and run to optimize with 1,000 iteration. And if I do that, well, my code is going to be way slower, but I'm going to have a nice breakdown of how much time each line is taking. So you have the line number, how many times the line was executed, the time the line took, the times per, like time divided by the number of hits, the % of the total time, and actually my code here. And so here, well, you can see that, well, my function was not super efficient. You see, well, it's relatively good, but I'm doing this computation that takes about 30% of my time, but it doesn't depend on J. It's relatively easy, I know. So here we were taking 332 milliseconds. Let's just try to move this one level above. Oops. Redefine and rerun. And if everything is fine, it should probably be faster. It may take longer to text because if timeit figure out that the function is faster, it will run more iteration. So you see here that it ran each time, it ran in like 10 times in a row, and my function is about twice as fast. And now I can rerun my my line profiler, and you can see that well, now the other have increased in proportional time because because this one is basically now taking well 0%. It's called way less often. I'm going to skim that, but what you would see is that it won't break down inside lines. But if you try to dive more into this function, you will see that actually accessing the zeroth value, the first and second value takes time. So it might be better to define TA and TB and do TA plus equal and TB plus equal, and then we would shave a few more seconds, a few more milliseconds. Couple of nice things. You probably work by Googling and copy pasting from Stack Overflow. You don't. I don't judge. I'm only judging you, Paul, because I know you answered to me on Stack Overflow, so I'm copy pasting your code. And so you will have some codes that already have this this prefix here, and it's sometimes relatively annoying to edit. Well, we are going to strip that and understands that it's actually Python code, so you can copy paste. If you want to amaze your coworker, so that works also in the pure terminal. If you are in the notebook, what you can do is actually do multi-line editing. So if you press, I believe on Mac it's Alt, you can do rectangle selections. You can also put many cursors by pressing Command and putting a cursor in many locations and type in 3 places at once. Can you do that again was the question. Yes, I'm going to do that. I'm going to do something else. I'm going to replace a variable with something else. So I'm going to use my mouse, and I'm going to use my thumb to press on the Command key on Mac. I believe on Windows it's Control. I wouldn't bet on it. And oops. And now what I can do is actually click on several locations. So I keep Command pressed, and I'm going to click here and click here, and that's all. And now I'm going to write B-R-A-C-A-D-A-B-R-A. And now I have a variable that has been changed several times. I believe you can also do double click to select 3 variables. So if I double click, I will select 3 variables and get back to A. And here I have 4 cursors, so this one I had to get rid of. That was fine. So do it. Do it again. Okay. You can just, you know how in your text editor you can have 1 cursor. You can actually drop many. Like it's exactly the same interaction as you normally have with your text editor, except on Mac if you press Command, and on Windows if you press Control, I believe, instead of removing the previous one, it will create a new one. So if I do Command, here I have a cursor here, if I do click, 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 I will have 5 cursors. So the original one plus 4 new ones. And now, if I press a key, the value will be done at those 5 locations. So whether I insert A, in which case I have A, I mean, I'm not going to do A because it's hard to see. I'm going to do X because it's bigger. I now have 5 X's. If I press delete, it's going to delete 1 character at all my cursors. So if I want to change a variable, I can create a cursor after the first one. I'm going to press Command and click after the second one, and the third one. So now I have 3 cursors, 1 after each A, and I type. I mean, here it's easier. If it's something bigger, you will do search and replace, right? You wouldn't do that, but it's possible if you want to do some multi-line editing. But if you want to, you can also select the words. So if I double-click on abracadabra, I will select it. So if I double-click here without pressing Command, I will select this one. And if I double-click here, I will select this one. What I'm going to do is select the first one, start to press Command, double-click on the second one, double-click on the third one. And now I have that selected 3 times. And now I can change it to PyCon. And now I have PyCon 3 times. Thank you.
Little things that make people happy.
Yeah. So the library. The library that does that, I mean, almost none of that was written by the Jupyter folks. It's written by the underlying library, which is called Code Mirror. So I'm going to get the code up. Let me do that. Code Mirror. So codemirror.net, this has a number of plugins and nice documentation on what you can do in your text editor. That's what does the highlighting and so on and so forth. So thanks the author of this library if you really like multi-line editing.
So it doesn't work for me.
Doesn't work for you. Let's see.
Because Control click gives me, it's like a right click.
Use Command click. Command click.
Command. Yes, it's Command or Apple for some of you who had Mac for a long time, because it used to be an Apple on the key before it was this weird clever things with 4 loops. Okay, and if you use IPython in the terminal, you will see also those things, and it also takes care of those things for you. If you're scared about tracebacks, I'm going to speed up a bit. You want to look at the X mode magic, which removes some of the information in traceback to be less scary. Or if you like tracebacks, you can make it more verbose, and it will try to find the actual value of the local variable. So here we are going to create several functions, and we're going to divide by 0, which usually computers don't like. Maybe in JavaScript they like it, I don't know. So that's usually what you get. You get your stack trace. You are in mode G and you called F, and in F you called x minus 1. If you know what you're doing and you remember all your 10,000 functions, you figure out that x was 1, so x minus 1 is 0. But it can be hard to get everything in your head. So if you do x mode plain, it will actually give you less information. Instead of showing you context, you see that here I have the line before and the line after. Here I don't have context. I only have where the errors are. If you have a really long stack trace, it's helpful. But in our case, we probably want to do verbose. And you see that the difference is it will try to say, well, what is the value of G? And G is a function. What is the value of F? F is this function, and also Y is equal to 0. And if in here, if F is equal, if Y is equal to 0, Y is equal to 0, Y plus 1 is 1. So now in F, we actually have X equal 1 when you do this. So we actually have figured out that here we divided by 0. So of course, here it's a toy example, but in big code, it might be relatively convenient. Of course, when you do that, it makes IPython slower. And it's not on by default, because you might write code that deals with password and authentication tokens. And so it's not on by default, and you can get back to the original value, which is context. Let's go fast, and we are going to go to break after. If you want to, we have some magics that allow you to run different languages. So here we write Perl, here we write Ruby, and it works. Subprocess, same as Bang. You can also run a debugger. So if you had a traceback just after you do debug, you're going to be in PDB. If you know about PDB, you can learn about that. So you're basically stopped in the middle of the stack trace, and you can say, well, what is the value of X? X is 1. Let me go back into G. What is the value of Y? It's 0. Let's go back to F. So you can debug interactively. So that's postmortem debugger. Just do % debug. Don't forget to press exit once you're done. Otherwise, you won't be able to continue executing code. You can ask the user for input. No, it's too slow. So you can get user input. And the one that you probably see often is matplotlib inlines that allow matplotlib to actually display things directly inside your notebook. You might see often sometimes other value here. So if you want the windows to pop up, you can change to Qt or WX or OSX, depending on which platform you are. We're not going to do that. And I'm just going to stop with this one, something we might want to see later, but Denis is not here, so we're probably going to go fast. If you want to go transform a function into something more interactive, I would advise for you to look for what Jupyter widgets are, and in particular the ipywidgets, package. So if you import interact from a ipywidget and you use @interact, you don't have to put all of that unless you want to do some modification on top of a function. What it will do, it will try to automatically make a GUI for you where you can tweak parameters. So for example, here I've just copy and pasted the code that was above, and it made a function with a plot, and it say, well, I want my color to be, the value of color here to be either C0, C1, or C2. My function is either to be a sine or a cosine. And I saw that lambda is a float value, so I'm going to automatically make a slider to make you change lambda. And so now if I want to see how this function changed when I change lambda, I move it, and it's going to recompute it and replot it. And so now I can basically say, oh, here it is with a sine, here it is with a cosine, and actually want the cosine to have color C1. So now if you want to have some interaction, you can do that using interact. You can build some really relatively complex UI if you go deep into this package. But usually, like using a single line after a function, you can basically get something which is interactive. And I think it's 10:13, so we're 2 minutes before breaks. We're going to stop the recording for a few minutes, let you get some, stretch your legs, get some coffee, and get back for the second round. I have some Jupyter stickers in the front if you want some. Stickers and stickers.
Thank you.
So you know on Jupyter Notebook there was like a community-based thing where they created a bunch of extensions.
Yes.
Is there any way to take any of those extensions from JupyterLab?
They need to be rewritten. Because in Jupyter Notebook you have a single instance of the notebook. And in JupyterLab you may have several instances. And so you basically get assumption in these all extensions that you only have one notebook.
Okay.
And so you can't just, because everything was global in the previous one.
Yes, yeah. Now it's specific to.
Yes. But the story for extension is way better in JupyterLab because it's officially supported. There is actual APIs, there is stability.
That's the whole plugin thing, right?
Yes.
Okay, okay. Okay, so I'd have to wait until like that particular person transferred
Or
write it
you
myself.
rewrite it.
Okay, thank you. Alright, so two really specific questions. One of them, for the multi-line select, like in VS Code, there's like a control T that'll take the highlighted variable.
Yes, it's there. I don't remember how to do it.
I can just look at the documentation then for the.
I think it's not in the default key map, but it's possible.
Okay.
Because you can, is it Control D? Because one of the things is settings. We won't see that advanced setting editor, card mirror. Control D is Sublime, right?
It's VS Code, I think.
I think it's originally Sublime.
You highlight first, maybe.
I'm pretty sure no, but I've seen it.
Yeah, but Control D is already mapped to something else.
But yeah, you can do it. You can go into the specific settings of Code Mirror or JupyterLab. I don't know how. And yes, you can bind your own keyboard shortcut for everything.
And then
almost everything.
Other question, in the Spider IDE, there's like a double percentage magic that is like an auto reload for imports.
Yes.
Does that exist?
I mean, it's actually come from IPython.
Oh yeah, I figured.
And it's one.
But I never
it's one
see
of my later demo.
Oh, okay.
I can show
Cool.
it. I can show it to you
No,
now.
that's okay if you're gonna get there.
Well, yeah, I'm probably going to have to speed up because I'm 15 or 20 minutes late on my schedule. So I want to show some of the later stuff. But yes, it works, and we're improving it. The latest version of IPython can do things with auto reload that the previous couldn't. It is limited, right? It won't do everything. But I think since the latest version, it's our two small version ago. It can actually remove and add methods from classes that it used to not do. It used to only add or reload, but now it's actually.
Separate things, tutorials, it's like trying to learn widgets, set up environments where I'm using installing. I think here, I think I figured out some of the so I was able to like create the charts for like the widgets to render, and I'm wondering if that's because I didn't do this in the virtual environment. In other places I've done it like in the room.
Yes.
So I need to install each installation of JupyterLab in a separate project I'm working on. I need to install the widgets in that environment, not just like.
Yes. Well, the other thing you can do, it's we can discuss that later, but you can actually install JupyterLab once outside of the environment. But after with some setup, what you can do is actually, you see here is Python 3. What you can do is here select the environment. So you can have one JupyterLab with many environments. It's not super easy, but it's doable. Like if you want to have one notebook in Python 3, one notebook in Python 2 in the same JupyterLab, it's possible. And usually that's how I am set up. Like basically, I will have one JupyterLab or one Jupyter notebook, and I just say, oh no, I want this notebook to be in this environment, this notebook to be in this environment. And then you don't need to do the lab extension in the environment. You can do the lab extension outside of the environment. You still need to have the widgets, the IPy widget installed in the environment, but that's way easier because it's just built.
Okay, I think that's the piece I missed. I didn't understand it. Like the extensions needed to also be in the environment. Every other time I've used it.
It's not super. It's not always obvious, but yeah, and we can work on that. I'm going to see if I can get something to drink. If the insertion is not working, there is a binder.
Yeah, it's working.
Okay.
Yeah. Got stuck in a very interesting. Do you dare try it again?
I don't know.
Double clicking something in iterm to the URL. She was stuck in.
So it's not doing it at all.
It depends whether you press command or not. If you press command and click, it won't behave the same as if you just click.
It opened like this preview-looking window, and we had no way of escaping it. But
Don't do it.
Don't do it.
Are
Are we holding it wrong?
have you tried turning it off and on again?
Well, I suggested you last time, so.
That sounds about right.
But actually, I wouldn't suggest it. I haven't done it in mine. Okay.
Yeah, I have one set up to kind of host a group of people. If I want to host more people, would that be more on the memory side?
It depends what people are doing. It really depends.
We do a lot of database intensive stuff, people using tags and load a query load the data from the database to a query, SQL magic, and populate that from results set to a data frame and then exit the data frame.
So if it's big data frames,
A few tens of thousands to hundreds of thousands.
So yeah, that might be memory. You probably have to talk to pandas folks. So yeah, usually people who use pandas and large stuff, because pandas has a lot of copy, are memory bound. But do you have, it's your own server or it's your own Amazon cloud? Like, is it like your physical machine, or is it's your physical machine? Okay. Is it it's academic research? Company. Okay. So JupyterLab in itself won't take much. What you might want to look at is, are users leaving long time notebook where they don't interact? Like, do they forget to shut down the notebook? And if that's the case, you might want to look into some JupyterLab plugin which will automatically stop notebooks that are not running. Like, if someone has not been interacting for 10 minutes, they just stop it. And so then you will use less resources in general. Otherwise, I would suggest to start to look at things that are not JupyterLab. Well, JupyterLab, but inside, using like Dask, distributed, and other stuff that allow you to distribute things across many computers. And where usually you want to set up things in a way where JupyterLab is actually a small machine, and what it does is just a front that will start each user on a different machine. And that's how you would scale. That's how you would scale to several hundred users. I'm not the best person to talk about that. You can try to talk with Paul, but I mean, most of the developers who are doing that are not here. So I won't be that helpful.
Yeah, but that's a very useful information. And one other question is, if one user wants to share his notebook with other users, is that enough on the server side to make that notebook read, write, execute for everyone?
So yes, as long as two people don't open the same notebook at the same time. Like, it's basically like if two people were to open the same file in Vim or in Emacs or in, it's the last one who writes win. We have a prototype of real-time collaboration that works with Google Document. The problem is Google deprecated that, so we can't release it. It works, but you need as a user, for your account, when you set up, you need to go to Google and say, oh, I want an API key, and you can't create new ones. So we can't release it because it works, but it's useless unless you already have a key. And anyway, at end of the year, Google is going to shut that down. And so most of the work is now to actually rewrite the backend that Google did. So write some real-time collaboration. And once you have real-time collaboration, yes, you will have ways of saying, well, like Google Document, you open a notebook, you send a URL to your collaborators, and they just open something, and they just like basically connect to yours.
All they are doing is execute and read, and that's fine. There's only one person writing.
So it does autosave. So when you execute, you actually change the notebook, and it will autosave. But if you set the permission right, if you set the permission to read-write for the owner and read-only for the group on Unix, that's fine.
They can still read and they can run it, they can execute it.
Yes, they just won't be able to save the modified version. They might get some error messages in the thing, like, oh, this is read-only or XYZ, but that should be fine.
Thank you.
Sure, of course. Where is he? Okay, so you can talk to him about. Oh, he's just there with a green shirt. It's fine. It's okay. It's just the sticky thing is not sticky anymore. On a what? No, not me. Okay, good. Sweet. I I know some people in the core team are working on the robot framework. I think you should talk to Nick Bolweg. Or in Google Jupyter-ROS, and those folks would be really happy to get feedback from you, I'm guessing. I can't. I have to leave on Sunday morning. Ask Paul and Matthew here in the green shirt if they are here. I think Paul will do it. And yeah, I mean, if they're around, I think we're happy to get some contribution.
Not as a class topic, but a question.
Mm-hmm.
Do you know of any good extensions or methods for reaching a DOM? So what I was thinking is that, well, there's some web automation. But instead of using some other keyboard running Jupyter in the browser, is it possible to like load an iframe?
Oh, you mean load an iframe in Jupyter?
Yeah. And then interact with it.
That I don't know, but probably I'm not the right person to ask. I would ask Paul, who is standing over there with a black coat.
That sounds like something Paul.
It might direct you to the right person. You probably mean the. So you can also display JavaScript. They probably need an extension for JupyterLab, but you can display JavaScript and get a handle on the elements where you do whatever you want. So, should we restart slowly? At least I'm going to give you tips to blow up your colleague's mind. So how many of you write math, use gamma, Greek letters, and stuff like that often? We have 2 people that know how to write Greek. Okay, so sometimes you want to have, we are always told that don't use variable names with only 1 letter. So of course you use, you use alpha, beta because it's easier. What you can actually do in IPython is if you actually want an alpha, you will precede it by a backslash, like in LaTeX, and you should press tab, and you will get an alpha. And if it's a derivative or actually a second derivative, you can put a double dot on it, and you can say that it's equal to whatever. And so now you can have your variables that are extremely compact. And so you can do that with many of the LaTeX things. Like if you want to have a force with a vector on top, here I don't have the font, but you can do stuff like that. Can I use emojis and things like that? Well, no, because they are not supported identifiers by Python. Like we only complete to things that will be actually recognized as variable names. So you can't do that. Not all the things are recognized by Python as actual variables. There are a few gotchas, like epsilon and var epsilon are actually exactly the same. So they can look different, but if I do epsilon press tab equal 1, and I ask the value of var epsilon, it's also 1. So there are some things like that, same for phi and var phi.
You monster.
What? So I know some people really like that, but so it was just to get your attention so that we can restart.
So, just so you know, widgets don't work for many people.
Okay.
Even though they installed them kind of forge, I'm not sure why, but in JupyterLab they do work in classic seemingly.
Can you try to force refresh?
Yes.
Okay. So if for some of you the widgets don't work, try to force refresh, because sometimes your browser will cache JupyterLab, the first JupyterLab. If it doesn't, we can figure that out exactly how to install things correctly, so that you have widgets. We won't do much widgets, so that's a good thing. Okay, and let's slowly move forward, and let's make you Python experts at things that not a lot of people on Earth understand, which is the second notebook. So I'm going to let's redo things slowly. I'm going to close this notebook. Say no, I don't want to save it. I'm going to go to these things where you have a person running, hopefully on your laptop. I don't have it, I don't know why. So when you close the document, you have the document and you have the computation backend. You need to shut down the computation backend as well, so the kernel. You see that I have here one which is still attached to one beyond plain Python. I'm going to shut that down to free some of the resources on my laptop. You don't have to right now, but if you have tens of notebooks, they can still run in the background and use memory and a tiny bit of CPU. And I'm going to reopen this second one. So again, I can open and collapse things by clicking here. And once you open this one, you should see here that now you have a notebook running. Depending on what you're doing and what you're working on, you may have heard about a new thing in Python called Async and Await. And you most likely have heard that things are super complicated and it's hard to run, and we try to make that really easy for you. Especially if you're interacting with remote resources, like if you're downloading URLs or things like that, Async and Await can be useful for you to make it concurrent, so not parallel, there is a slight difference. It won't make your code magically faster, but it may make some of the tasks you're doing when you're waiting from something which is remote easier to work with. So just as a quick introduction on Async and Await and trying to understand what it is, it allows Python to interleave tasks. And so usually the way your computer does that on a day-to-day basis is just stop a task in the middle of what it's doing, the CPU does that magically, and it starts another task. And so you may have heard about threads. When you do thread, it's that, you have different tasks, and you will have preemptive multitasking. The CPU will suddenly say, nope, you stop, and you start. So that's the OS level. What we can do is move that at some point at the Python level, but we need some kind of agreement. And so to take a metaphor, when you're going to a restaurant and you're going to get seated to a table, the waiter will be able to take care of several people at once. It will be able to take your orders and the order of a next person. But you have social conventions that tells when the waiter can move from your table to another. He's not going or she's not going to leave your table while you're giving your order. And at the same time, the convention is that you won't hold the waiter here if you're still reading the menu. You say, no, it's fine, I'm not ready. You can take care of somebody else. And that's basically what Async and Await are in Python. You basically have to say at which point Python or the scheduler is allowed to move from one point to another. And so that's why you can have this weird syntax. You say, well, if I have a function which is async, it may be interrupted in the middle. Like basically a function going to the restaurant is going to be async because while you're going to the restaurant, you may at some point, like the waiter can go somewhere else. And so if you try to do that, some of what I've seen here in pure Python or at the top level in the Python file and do python.mypython file, it might not work. So let's deactivate IPython automatic integration with this magic async and await and try to run some code. And so let's say, well, instead of importing from time, I'm going to import, probably zoom a tiny bit, import from async.io, and I say, well, sleep 5 seconds. Right? It didn't sleep. is because you actually need to await sleep, because sleep, you say, well, you can do something else while you're sleeping. But if you do that in pure Python, it will just say, no, it's a syntax error, I don't know how to do that. Let's skip a bit about exactly how you would try to solve that, and that doesn't work. And so what you can do in IPython is start with auto-await equal true, and say, well, if you see an await, and I haven't told you how to deal with that, do something magic. And so now, what we can do in IPython that we can't do in pure Python is just have a sleep 5 with an await, and then you have before and after, and it slept for 5 seconds. So sleep is not really interesting. So let's try to do some interesting things and try to get 50 results from an API of ice and fire characters. Let's get the 51st character from this API. You may have guessed where this is coming from if you're watching HBO on Sunday. And so let's try to ask for the first character, get it, and do a loop with that. But you will see that in a normal Python, if you use requests, if you've used request before or you are on lib, what's happening is it's relatively fast, but you see that you start a request, get the response, and start the next request after the first response came back. So here I have only 50, and so it took quite some time. And if you look at the CPU of my machine, it was not going to the maximum. It was basically doing only one task at a time. And most of the time, it's spent waiting for something to happen. And so what async and await will allow you to do is to do that concurrently, which means that the computer will be able to start many connections at once without having to use threads, and start the request for the first character and start the request for the second character before the request from the first character is ended. If you want to really know more about how to use that, I would suggest one of this afternoon tutorial on AOHTTP. So we are just going to see how we can use that. And so what you can do in IPython is to just import AOHTTP, which is similar to requests, except every now and then you have to await the object. And when you await the object, it means that something else can run at the same time. So this is how to use AOHTTP. You have to create a session, and then you have to manipulate this session and ask this session to get things. So let's try to get a single result. So here is someone who knows nothing. Let's put that in a function, async def, like that. And let's see if we can just, so this function is async def because it uses await. You can't use await in functions that don't have async. That's about everything you need to know. Now we're going to, again, do this client session and await getting these characters. And again, this just works in IPython, where in pure Python it will be a syntax error. So now, if you want to speed up looking at who has died in the last seasons, because everyone is dying anyway at some point in this show, what you would do is do a for loop, and you will create, you say, well, I want to have this 50 task where I will get the character, the nth character, and you create a list of those things that you want to do. And what you will do after is just await from all of the things you wanted to do. And because now they are, we can see here, they are async def, it means that on this line, each of these functions you called can be run concurrently. So you will have the ith, like the 12th and the 23rd that will be running at the same time. And so now, hopefully, what should happen is that we will fetch the first one and start to fetch the second one before the first one is actually there. And you see that, well, suddenly getting 50 of those characters was way faster, because we were able to actually start them all in a bunch, and then hopefully if it took 1 second to get one character, it takes only 1 second to get 50. Does that make some sense? And so what you can see here is that, well, you might not exactly understand how each of the library works and which call to do, but you won't have, in IPython and in Jupyter, you won't have to mess with creating your own event loop or submitting tasks or things like that. You can just use normal syntax at top level without having to create an application and run the thing. So that's just to tell you that if you want to touch async and wait, you can do that. It's not as scary as people show you online. And we've been working hard on that. If you don't want to use async IO, there are also other libraries that do async and await that are sometimes easier to use. And so what you can also do is tell IPython to use those. So just to show you, if you want to have 2 tasks that do things like one every 2 seconds and one every second, we will use this other library. So here we will create a function that sleeps for n seconds and then print a message. I'm going to do it only 30 times just to avoid having an infinite loop. I'm going to tell IPython to use trio, because here I'm using sleep from trio and not async IO. And what I will do here is start 2 tasks. One, I will start every task every 1 second to print plick, and the other one every 2 seconds to print plock. It's useless, but and now, if everything is fine, you have 2 concurrent tasks running in your notebook. So if you're interacting with a remote service and you want to check something periodically, you can do that relatively easily, and you see that it keeps working, and you didn't have to use threads. So that's some of the new feature in IPython 7 or 7.2, I don't remember. I'm going to interrupt that. And let you, is everyone okay? Do you want to play with that, or is it maybe too advanced? Too advanced, okay. Now we're going to go back to the terminal, because IPython is what powers running Python, and even if things are possible in the notebook, they're also possible at the shell. So what you can do is you can either follow along in the browser. What you can do is to go there, create a new, scroll down, and a new terminal. Or if you have your own terminal you like, you can also go in your own terminal, and don't forget to activate the PyCon 2019 environment. And let me just use the light theme, because I'm going to guess you're going to see better in the light theme. If I can zoom in.
When you launch the terminal, does it just automatically launch whatever your default terminal on your system is, or is it always a bash prompt?
So the question was, if you launch a terminal, does it automatically launch a terminal on your system? It should. I know there might be some issue on Windows where it might not be able to. Sometimes it will try to run command on PowerShell. And it might be some issues there where we might need to work on that on some machines. Of course, if it's tries to run bash, you need to have bash installed. Depending on how you, with Anaconda, I don't remember exactly what it does on Windows, but depending on how you install on Windows, it may sometimes start bash or sometimes start PowerShell, depending on how you install it.
Okay, but on Mac or Linux, it would just run whatever your default.
Yes, on Mac and Linux, it would run whatever the default is. And it's compared to other in-browser terminals, this is a full-feature terminal. So if I want to use Vim and play with Vim, I can use Vim in my terminal. You don't have to. I'm a Vim person. I can't quit. I'm stealing Paul's jokes. Okay. How did I launch a terminal? Good question. We're going to see the JupyterLab UI later, but usually if you go on folder here, you have these new things that create those panels here. Let me reopen that and close the launcher. If you press plus, it will open a launcher. And the launcher allows you to create Python notebook. I also have a bash kernel, so I can create bash notebook if I want to. Console, I'm not going to see that. And terminal and text file. And if I click on terminal, it should open a terminal here, which says terminal 2. If I go to my running things here, that I still see my old terminal, terminal 1. So here I have my 2 terminals. I'm going to close terminal 1, shut down terminal 1. And I have my terminal 2 here. I'm going to close my notebook and shut down my notebook. Again, I'm going to go there, click plus, and I can go to terminal. Or if you close all your tabs, the launcher automatically appear, and you can go to terminal.
What does the little red X indicate in your terminal?
So that's a custom thing that tells me that I have, it's a Git repository, and the Git repository has changes. It's not specific to Jupyter, it's specific to how I configure my machine. And that tells me I am in the PyCon 2019 branch. I need to do conda activate PyCon 2019 if I want to be in the PyCon 2019 environment. And if I want to change my PS1, if that is too long, I'm just going to collapse that. That's more bash things, but you can do PS1 equal, is it H? No space. No. That work. I don't know why. Anyway, probably did something wrong. Whatever. That's my own configuration. Sorry about that. Let's erase the screen and let's start IPython as a REPL. So that's a pure terminal IPython. That's strange. It's 7.2. It should be 7.5. But anyway. So unlike normal Python REPL, we have way more feature in the terminal as well. It is a full-fledged terminal. It's not using a kernel like a notebook, which means that some things that you can't do in a notebook, you can do in a terminal. So for example, you've seen in a notebook that I was using cat, and I don't remember the name of the file that we did was log.py. So in the notebook, I did cat log.py. But one thing I didn't tell you is that you can't run commands in a notebook that ask you to interact with them. Like in a notebook, you wouldn't be able to do bang vim, or the notebook will hang. In the pure terminal, you can actually call things like that. So if I do bang vim log.py, I remind you that bang runs something in an underlying shell. Now I should be able to just edit my log file. And quit if you know how to quit, or you can use nano if you prefer to use nano if you know what you're doing in a terminal. I can exit. It just means that you have more power when you want to run subcommands in the terminal, especially subcommands. We will ask you to interact with them. Like if you want to do apt-get install and interact, you can't do that from a notebook. You can do that from the terminal. It also means that we allow you to do some of the stuff in the terminal that is easy. So if you define a function, let's say I define Fibonacci, which is definitively wrong because it returns 1, and actually Fibonacci needs to take a number. After some time, it's going to be annoying to edit something really long. So what you can do is you can actually configure IPython to tell it what your preferred editor is, and use, well, I want to edit my Fibonacci function, and it will create a temporary file, and now you're in your favorite text editor, and you can edit your function. If you like to use Sublime Text or VS Code or Atom, those editors have specific flags that you need to pass to them for this to work, but you can configure and say, well, open an Atom window, and when I close the Atom window, tell IPython to continue where it is. So now you can properly define your function and yes. So you see, like now I saved and quit my editor, and it brought me back to IPython and updated my Fibonacci. So now if I do fib of 3, and I will redo that again, now it's returning 2, which is still wrong, but principle. So you define a function. Let's say you define a function, my function. And you want to edit it at some point in the future. Once you've configured properly IPython, you can do %edit, which is one of the line magic we haven't seen, but it's a line magic because it starts with %, and then you tell it the object you want to edit. So my underscore function. And what it will do, there are error messages, but that's my system. It will create a temporary file on disk, invoke your editor to edit this file, in a blocking manner, whatever. Now you can edit that So if you haven't configured by default, it's going to be Vim, so you might want to have to quit. So you edit your function. So I want to write in Vim, so I'm going to press I to be in edit mode, in insert mode. So you know that there is insert here. Now you say you change your function using your editor to return a value. It's Vim, so I need to press escape. I need to press colon WQ, and now my function is has been updated. My function. I need to call it if I want to get the value. That's not the best way to do it, but it's just to show you that you can interact if you want to. You will see that we already have a lot of things in IPython, like we have syntax highlighting, we have type completion as well, which is relatively advanced, like in the notebook. Import numpy as np. If I do np dot and I press tab, it should take some time at the beginning to show up because it did inspect things. It gives you all the completion you can do, and one of the recent new thing is when you highlight one of them, it will try to give you the type here. And if it's a function, it should try to tell you the signature of the function. So here it didn't have the chance to compute everything when it said unknown. When it says unknown, it needs to actually get some more time to complete things. So I re-invoked the completer. And you see that now your functions, you have parentheses because they are functions, and it will give you the signature of the function here. So you know that numpy add new doc. Well, add new doc is maybe not super interesting, but maybe array is. And you see that array is a function that take an object, a dtype, whether you need to copy, which order, and other parameters. And so one of the things we have, especially in IPython, yes?
I'm sorry, but what mode are you in right now? Is that a terminal, a console?
So that's a terminal, that's a pure terminal. I'm doing that in my browser, but I could do that in iterm if I wish to. I can open iterm, which is super small, and I could do IPython in my terminal, and now I have IPython.
Oh, you're in a terminal and you ran IPython, okay.
Yes. So that works on a remote cluster if you're on an SSH or something like that. Let me come back to this.
If you ever just try to type some quick Python, IPython usually is a lot nicer than just Python and trying to use the idle, at least for like.
So Matt said that using IPython to write some quick Python is way better than using idle. Not my words, please. Well, yeah, because we have syntax highlighting. Again, we have syntax highlighting. You will see a lot of tutorials that tells you to use a Python REPL. But for quick things here, we have multi-line editing. Like if you do for I in range 10, print I. Well, you want to do range 12. In the normal Python REPL, you can't go up. You have to rewrite the thing. In IPython, you can. It's small things, but a lot of really small things that are helpful. And so that should just work. What was I going to say? Yes, but one of the things that you might want to do is develop a library next to it, or have some code you want to update that you don't want to iterate over in a notebook or prefer in a file. So I have here. Demo autoreload.py. It's a small library I used that, I was bad at math at the time, that tried to compute the square of a number. It's definitively wrong. It's multiplied by 2, but you know it works with a equal 2 actually. If I do a equal 2 and I try to square it, it works. And I want to develop that. So one of the things you may have learned is that you can't reload a Python module. You have to quit your interpreter and come back if you change your py files. We do our best to allow you to do that in IPython. You have to opt in. And so let's try to do the normal mode. Let's do from demo autoreload import my class, and then do c equal my class of 2, well, because it works with 2. And look at the square of 2, and it's definitely 4. That works, right? If we do with 4, well, c square, is not right. That's not supposed to be 8, it's supposed to be 16, probably a factor of 2 somewhere. That we miss. Here, if you were to modify that and put like actually square, it wouldn't work. So let's quit IPython and restart, just for the sake of restarting. And this time, we are going to do load ext, go back to the beginning, auto reload. So that's set up something in IPython. It's now slower, but it has some capabilities of reloading code on the fly. There are different modes. You have either explicitly telling it what you want to reload, or just try to reload as much as you can. We're going to be lazy and do auto reload mode 2, which is try to reload as much as you can. And now we're going to go back and import my class. We're going to create C, which is my class of 10, because square of 10 is relatively easy to compute. I don't remember the other one. And realize that C square is wrong. But now, if everything works fine, if I update my file with just a new star, I save it, don't forget to save, and compute C square, it has updated our thing. And we didn't have to rerun our code. So here it's relatively simple, but you may have a big data set and a library where you want to run something on the data set. And the data set might take like 5 minutes to load. Same thing is if you do C cube, well, that does not exist. I'm going to do the same thing that you apparently liked earlier, is to select multiple things and delete at once. Question? Does it work if a module import another module? It depends. It's a best effort. Well, not in the sense that we do as little as we can and we just want to tell you that we're doing our best as we can, but we literally do as much as we can. But not everything works. It's really on a case-by-case basis. If you really want to be sure, you have to restart your session. So I know some of the things that don't work, I know some of the things that works, but it depends. It does more, if you use import live with a reload function, it uses that internally plus some other things.
But as for his question, if you wanted to force it to reload something, by using reload from import live, will that?
Well, it does use import lib reload, but it does some extra things on top. So using import lib reload explicitly will probably not do more than what auto reload does. Maybe. But I'm unsure. And another question there.
Just wanted to check. I assume you can make changes to init. You would need to reinstantiate a new instance of the class for that to take effect.
So that's correct, and that's what I'm going to show there just after. Is if you change init, you would need to you have to reinstantiate the class. Like we can attach and remove things, but things that happen in init are not propagated. So let's just do it. Cube is now defined. But if I do something like self b equal 1 over a, c.b will not be defined. I will have to redo c equal my class and c.b. So we do as much as we can, but we can't do everything. Everything that has like also we try to reattach method, we try to update things, and so you will have weird HKs. But that is extremely useful when you actually want to develop a library, because you can have something which is almost as if you were to completely rerun your script, but it will try to update as much as possible from your namespace. I would again advise you to look at auto reload question mark. So that's a bit big, so let's do that. It tells you what are the different things. You have auto reload 1, auto reload 2, and auto reload 0. Auto reload 2 try to do as much as it can. If you do auto reload 1, you can't just import something. You have to use %auto reload import. And if you do that, it will only try to reload these specific things. It can't reload things that are compiled in C, If some of you develop C, write C, but I would advise. I think that's good enough. Is there anything else I wanted to say about that? Maintaining editing, maintenance process. So that's about it. So that's IPython. Paul has a comment? Question?
Just a quick question. Is there an easy way to save what you've done in the console kind of way? How would you put up with?
So is there a way to save what you've done in the console in the Jupyter notebook? We've seen one thing at the beginning of our session that was history. And history will tell you everything you've done in your console. And so now what you can do is actually make it to a file. Oops, I forgot. Come back. You do history -1 or -2. Oh, and you need to do 100. You can get previous sessions. I don't remember how to do that. Yeah, here you go. So 1 session ago, line 1 from 100. If you want to, technically, all of that is stored in a SQLite database in your home. So don't type your passwords in clear. Don't put password equal and your actual password. Because otherwise it will be stored in the SQL database. You can purge it, you can do stuff, but yeah, everything is stored so you can come back in time, see what was done, and small results are string small results are also stored in the database, so you can also reaccess some of the outputs. But that's a detail. Okay. 4 was Jupyter. Yes. Can you what? Can you play back on history? Probably. I wouldn't do it because often you have like a thing that you have to back and forth. You often have mistakes, so you probably want to export the history to a file, edit the file, and then once you have a file, you can actually. The question was, can you replay a history? You can use the run magic. The run magic allow you to, in different ways, there are options to run a Python file almost as if you had typed it into the REPL. You wouldn't get the input and output. You could. There are options. There are many options. But I mean, at some point, I want to discourage you for just doing that and more thinking. If I have a thing that I run often, you want to make a Python module out of that. You want to make functions, and you want to call your functions. Like you don't want to venture too far from normal Python. And at some point, like there is convenience. And once you moved away from convenience, you can make them into a PY file.
There's this great interface for tracking, little IPython snippets as you're writing code called Notebook.
We have a sarcastic comment from Matt in the back, saying that there is nice things to track snippet of code called Notebook. Yeah.
It does help for these type of things. It's tracking the history for you, so you can delete the things you don't care about as you go. That's like one of the value adds.
That is it. You have different way of doing various things, and I have something in my head that I forgot now. It's fine. Plenty of things. Look at the IPython documentation on ipython.wizard.org. There is way more on that question.
Quick question about the database that stores the history. Does it store the outputs as well? So if you did something like print a environmental variable that has your password, is that?
So does the database also store history for the input? It does store some of the output. I don't remember the exact criteria, but yes, I believe if they're small and purely text, and less than, I don't remember, 100 characters, they're going to be stored. So, yes. Okay. So now I was going to go to the folder number 4, I'm going to describe a tiny bit of the JupyterLab UI so that you know a tiny bit what you can do if you're working in the browser. So you've already played a bit with it. one of the features of JupyterLab is that everything is a plugin. So even the core components are plugins, and if you want to swap them, you can. So that means that it's extremely flexible. I'm going to unzoom a tiny bit to be able to get some real estate, because now the exact content of things are not that important. You've already been familiar with the launcher. If you install a different kernel, the kernel will allow you to create notebooks in different languages. So here you see that I have two. I have Python and I have Bash. You can change after the fact. So here I created a Python notebook. You say that it says Python 3 here. I can change it to actually be Bash. And so now I'm actually not writing Python, I will actually do Bash. If you have several virtual environments or conda environments, there is also one way to have here Python for each of the conda environments. I'm not going to do that today. The other possibility, and we're not going to dive into that too much because of time, is if you have already a notebook with a kernel, you can attach another notebook to the same kernel. So you're basically sharing namespace, you're sharing your datasets, you're sharing your functions, but you might want to have a scratch pad where you just do run some small analysis and an actual notebook that you want to do for a report. And that's possible here again. You just create a notebook and you just attach to. So how do I got that? I'm going to redescribe the UI. So here it tells you which language your notebook is in. It's actually not which language, it's usually which kernel. The kernel, the name of the kernel doesn't have to be equal to the language, but it's a default. So here you see that I have Python 3 or I have Bash. I could have something called Python 3.8, or I could have a kernel called PyCon if I wanted to. So that's specific to each kernel and how to do that. So you're just going to go here to the language. This is just a quick way of doing it. There are a more generic way of doing things. You do have to have the kernel installed. You probably don't have Bash. I have because I have it installed. And it's across all of the Jupyter things. So if you use Interact or if you use the integration with VS Code, you will be able to see those kernel as well. This indicator that you might have seen is kernel busy. So when the thing is doing computation, it will be black. So import time, and not Bash. I want to actually do Python now. Time.sleep10. You see that it's actually busy running. So that's a quick way of knowing whether computation are actually happening or if something is just stuck. You will also see that the number becomes a star when something is running. But this is slightly more accurate. You have a number of shortcuts here. Change the type of a cell to markdown if you want to actually write some markdown, and then press Shift-Enter to render. So that's relatively similar to the normal notebook. I'm not going to go too much into detail of what you can do inside the notebook. I will let you play with that. You have the restart kernel. So if you're not sure if what's happening and what you have done and not done, if you press that and you press restart, then the kernel has been killed and a new one starts. So now you have a fresh namespace on which you can rerun things one by one and make sure that your computation actually does the right thing. The shortcut to restart is when you're not editing a cell, but when you're actually in command mode, you can press 0, 0 twice, or 0 twice, and it will bring the same dialog. Question?
Question about the cells.
Mm-hmm.
In Jupyter Notebook, there's a plugin if you want to convert them, if you don't want to make a PowerPoint to convert them to presentations.
Rise?
Yes. Is that the same thing we would use for JupyterLab?
So the question is, there is a plugin or normal notebook called Rise for Reveal, JS, IPython, slideshow extensions that allow you to convert a notebook into a slideshow. Is there the same thing for JupyterLab? I'm not sure it has been completely updated to run with JupyterLab, but because the files are the same and exactly the same, what you can do is close it in JupyterLab, go to Help, and launch Classic Notebook. And now you're back to the classic UI. And from the classic UI, then you can open your things and start the Rise plugin if you're a Rise user. Or for any extensions that does not work with JupyterLab yet, you can just come back to the old interface and use that. Don't open the same notebook in 2 interfaces at once, because it's the last one that writes to disk that will win. So I'm not going to go into detail on how to go to normal notebook, but let me just go back to the tree here, and go back to lab, and I should be back here.
There's also command line, but those extensions are called oftentimes command line calls, so there's command line as well, or if you want to automate like outside of the UI.
And the comment that Matt said is that there are also command line tools for all of that, so you can also use the command line tools. One of the things you question.
Yeah, while you're on the topic of classic notebook, is there a difference between running JupyterLab and then changing the URL to /tree?
The question was, is there a difference between starting Jupyter, but changing the, like what I've did, help launch classic notebook and change the URL to /tree? No, it's the same. It will work in some circumstance, like it kind of is aware of Jupyter Hub and things like that, but it's mostly that we don't actually want users, and users should not need to know the URL structure. So we have this nice shortcut as a convenience. Yeah. And it's actually not launching. There is nothing that launch. It's already running. It's just like switching the URL. One thing you should be really familiar with is this palette here called the command palette. Here you will find all the action you can do in JupyterLab, regardless of whether they are in menus, in right clicks, or even not available anywhere else. It's basically like searching everything you can do, and you can see that you even have the shortcuts that are shown on the side here. So for example, if I have a notebook and I want to change the kernel from Python 3 to Bash, it was one of the questions I had before. I would go to search. I could either click here and get the select kernel, or I can go here and do kernel and search for, I have restart kernel, I have clear all outputs, and I have the change kernel menu. And if I click the change kernel, it will pop up this window here and ask me what kernel do I want, and now I can switch to Bash. You could do a lot of things. Let me open a bigger notebook from before. Let me reopen this one. I'm going to close my untitled one. You see that I still have my prompt number of what I've done before, but I want to basically like clear everything, every output from my notebook. I would go to the command palette here and search for clear. I have clear output for a per cell operation, and in notebook operation I have clear all outputs. And if I click that, well, all my outputs and prompts are now gone. And so that's relatively useful. I would suggest you learn keyboard shortcut as well, which is, at least on Mac, if I'm here, I can press Command-Shift-C, and it will bring that. And so now I can just look for what I want. I want to run all cells, and now it's going to run all cells one by one until it finds an exception, and then it will start. So if you want to run one notebook completely from top to bottom, you could restart your kernel to make sure your namespace is clean, and then do run all cells, and it will run them one by one until there's an exception, and then say, oh, well, this was wrong, and you can fix it and make sure that your notebook is actually same. Because it's a completely new interface from the classic notebook that some of you may have seen, there is a lot of new features that were not possible in normal notebook. So I'm going to go back here. That's the exercise one. I want to open that. We can render a markdown file, for example. So if I have a markdown file and I double click, I will get the markdown file. Markdown might be hard to read, so what you might want to do is right-click here and say open with and the preview one. And so now you actually have a render markdown file, which is easier to read. And I'm going to collapse that, and you might want to edit the markdown file. So that view is nice to edit, that view is nice to view. So, well, can I have both? Well, yes, you can drag tabs around. You've probably seen that before. And you will have a blue indicator that shows you where on the screen you can put that, and I'm going to put them side by side. And they are actually different views on the same model. Both are actually, like if you edit one, the other one will update live. So here is, with a few seconds of difference, some modifications. And so now you can have the same thing open in two different ways. So you can, for example, or even like the same one twice, and you want to copy things over between two different locations. So let me remove that. So in the folder for JupyterLab UI, you should have some exercise, and well, I would suggest we take 5 or 10 minutes to go through that and try to play with the UI. There is some guideline here of things that you might want to try. So that you get a feeling of what you can do with JupyterLab, and then we'll do. I'm going to run through that and show you all the features. But I think it's best for you to take 10 minutes to see what you can do. It also show you some of the Python stuff you can do. I'm going to close that. You have the sticky notes. If you're already finished and bored, you can put the green one. If you have issues, you can put the red one. If you want to go get something to drink, you can also go get something to drink. We have stickers in the front also, Jupyter stickers for your laptops. Single click will just select, and double click should be able to open. Okay, I don't know, I haven't seen that before. If we look at activity monitor. No, it should be fine. CPU load is fine. System user, memory. Memory is fine. I don't know what happened. It seems to be enough. And you can't run. Oh yeah, nothing. Okay, that's weird. I don't know. I don't know why. I mean, it seems to work now, but that's relatively fast. So that's fine. That's normal error. Error, yeah. Just 10 is not the right number. It seems to work now. I don't know. We can try to sit down later in the week and recheck everything if you still have issues. Yes. You can. I don't know. You have issues?
So I managed to find a new view, but how do you renew that?
Okay, so right click on the tab of one, and right click in the file itself and show markdown preview. You can also in the file browser here, if you right click on the exercise1.md, you can also do open with, and you find either the editor or the markdown preview. right-click in here, right-click on outline.md or whatever, you can open with editor or markdown preview.
Oh, so you just be open to,
There are different ways of doing it. So if you go to so here is a preview, and here is normal one. You can also right-click here and show markdown preview. Well, it's here now.
where did you do that?
If you click in the middle, it will do show markdown preview. There are different ways. Berto. P-L-O-T. Oh. Okay, so that's a typo for me. So there is a typo here. You don't know Markdown? Okay, I'm going to go through it. Markdown is 2 star for bold, 1 underscore for italic, like in each side. If you put hashes at the front of the line, it's the header number.
Okay, what about for the math?
It's dollar. Like I have the example, and single dollar is going to be 9 math, and double dollar is going to be display math.
Okay.
that's why we do some of the tutorials to get some of these issues out. But yeah, I feel like there are other extensions that I wish there was in JupyterLab and all of them. Try to speak from Jupyter as a single voice. I know why it's easy to use some
Cell magic?
Yeah.
There's no way to get custom syntax highlighting based on the extension.
On classic notebook, yes. On JupyterLab, no.
Okay. It's just useful for demos and stuff. We try out like it's not a big deal.
Yeah, no, don't forget it's because it's introduction to both the kernel and the front end, but yeah, I see where you're coming from.
Okay.
I'm just
Sounds like you have it.
well, it's something that bothers me a lot.
Okay.
I know how to do it in classic notebook and JupyterLab I think how to do it. Maybe one of the things would be to write a custom extension for JupyterLab that would change the highlighting depending on the parameter you pass to write file. Like detect write file.
Oh, it does the processing in the front end.
Yeah, the highlighting is the front end.
No, that's for sure.
But you could basically say, well, if you see write file, look at the second file, and can you have something that automatically detects the highlighting depending on the file name? So that's what you need to apply. Just I don't know enough about the kernel.
I know this because it uses stuff I love.
Yeah, and in normal notebook it shouldn't.
Yeah.
Can you switch to the terminal while you start with JupyterLab? No, it doesn't give any error messages. Can you go back to JupyterLab? Settings, advanced settings editor, extension manager, and in the square brackets here, put quote enabled, quote colon true, no quote true. Save, enable, and the new thing that appears here. It seems that the widget extension was not properly installed. So that's why. And so then widgets are not working. You know, it doesn't matter. I mean, it's JSON, so it's lowercase t. Or maybe, oh no, it's installed. I don't know then. We can try to debug that later in the week. Maybe they can.
Yes, because node is the biggest factor. It's the node, yeah. So it's trying node. Okay, so it's the node.js one.
Okay, let's try to move quickly forward. Some of the solutions are in the example notebook here. So some of the people struggle because I was too fast before. So let me show again how to create these two markdown things. You have several ways of doing it. So if I double click on the exercise 1.markdown, I get the edit view. I can either right click on exercise 1 and do open with markdown preview, and then it will open a markdown preview, and then I can put each of the preview and the edited next to each other. Or I can right click directly somewhere in the markdown file and do show markdown preview. I'm going to get rid of that, and now I have the preview as well. You can also try to click on the tab that some of you did. You see that there is no way to get a preview, but you can make a new view. So there are slight differences depending on where you click. And one other thing that you might have seen is create console for editor. We're not going to dive too much into that, but you can actually attach any file in JupyterLab to a kernel. And if you have here something that say print hello PyCon, that's going to show you so that you know it's possible. And close the triple quote, which is a way in Markdown to show code blocks. If you go there and press Shift-Enter, oh, missing a quote here, press Shift-Enter, it will actually take the code block and sending to the console to execute it. So if you prefer to write something like more like R Markdown, but Py Markdown, you can do something similar. Let's close that. Let's reopen the app solution. So what you see is here, like we have some example of notebooks that show what a few things you can do. So here it's Markdown. If you press Enter to edit, or if you double click, you will be able to edit. That gives you a quick reminder of the Markdown syntax. If you use GitHub or some other website, you might know it. We can have math, either display math when you have $2 sign, or inline math if you have a single $sign. You can write a subset of LaTeX and do Shift-Enter to render. Some small differences between when you use backtick for the language with 2 L's because my keyboard is broken, or 4 spaces. One will be highlighted, the other will not. One of the things that we've slightly seen before is that objects do not need to be pure text. They can actually be displayed as LaTeX or as PNG or SVG or interactive stuff. We're going to see that later if we have time. And then it's just had you go through some of the kernel functionality, like having a question mark to get some information, how you could use, we didn't import it so it won't work. Import pandas as PD. Press tab to actually complete to the data frame. Once I have my data frame, I can use Shift tab to get the signature. We've seen that. We've seen the shell escape with bang. Now you can see how some objects of some libraries are already nice represented in HTML and not purely text. How Matplotlib, as there was a typo somewhere, can actually render inline graphs. If I don't execute everything, it won't work. Let's print something long. If you click here, you can collapse, or if you right-click, you should be able to find how to make it scrollable. I can't read from here. Enable scrolling for output. So if you have a long output, it don't take too much space. You probably have read that you can, when you see these 4 arrow things, you can drag cell around. If you have a second notebook next to it, you can grab a cell. You should be able to grab a cell and move it between notebooks, so you don't have to copy and paste. So there are a lot of small things like that that make, so many things that I won't go through everything. You have the shortcut here, like undo cell deletion, cell operation, reduce cell operation. On scatter. And here, well, something if you want to have some JavaScript, you can have some JavaScript. You may have seen, depending on exactly how you do that, hopefully when you load it the first time, the things did not appear. But on my machine it did, because I already ran the full notebook once. So we have a notion of trusted notebook. There are security vulnerability if a code you don't trust can run JavaScript in your browser. So once you have run a complete notebooks once from top to bottom and saved it, we will keep a file on your computer that says that this notebook is trusted. And so JavaScript that is in this notebook, because you were one of the last person to completely run it from top to bottom, this notebook is able to show JavaScript at load time. So what you will see is that some notebook might not look exactly the same when you receive them from someone and after you have completely executed them, if that makes sense. If it doesn't, you can come back to us and we can talk about that. But basically everything which is JavaScript based and interactive floor space might not appear exactly as it does when you load the notebook from an external source. Any questions?
Is there a way to make it trusted?
Is there a way to make it trusted? Yes. You go to the command palette and you can do trust notebook. Well, in that case, when you do that, we trust you. But if there is any code in the output, if the notebook has been forged, and well, that's basically the equivalent of accepting an unknown Excel macro or an unknown Word macro, and you probably have heard what's done in the past. So it's up to you. You can do that. There is also a command line thing if you do Jupyter notebook trust, or is it just Jupyter trust? Yep, seems to be Jupyter trust. Does help? Yep, you can pass it a number of notebooks, and it will trust them so that when you open them, the JavaScript will be displayed. Any more questions?
So, I mean, I'm used to the sort of the original Jupyter notebook experience, but if I'm in the lab and I have multiple notebooks and I restart, like I want to clean up the in numbers, so I restart a kernel, will it affect the other tabs that have other?
So if you have the same notebook in multiple tabs?
No, just you're opening multiple tabs to do work, not the same notebook. You know,
Like
I did the
Chrome tabs, like browser tabs.
No, in JupyterLab, like a second notebook. You did the.
Okay, so the question is yes. If you have several notebooks and you have two notebooks here, I have exercise 1 and Untitled Chapter, and I want to clear all output, and I go to command palette and I go to clear all outputs. Will it affect one tab or all tabs? So that's the question.
I was going to restart the kernel.
Or restart the kernel or clear tab. It should affect only the current running, current focused notebook. So here it's discrete, but you will see that untitled.ipynb at top has a blue line on the top of the tab, and so that would only affect the one which is in focus. And so if I restart, it will also restart only the one which is in focus. I don't believe there is a way to do that for all notebooks. If you want to do restart for all notebooks, what I would suggest is go to the running tab here and just do shutdown, 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 shutdown. And now it will say, well, no kernel for this notebook. Let me just get rid of that one. It says no kernel because the kernel is gone now. You can redo Python 3, and now you have a clean thing. You have a shutdown all, but I don't think you have a restart all. It's possible to add, I think it's an extension. Let's see if there is a restart all, but I don't believe there is. No, there is not. But we could add that if necessary, because everything is plugin based. Other questions? Or we move on? We have, okay. So let's go to rich display. So we're already at 5. That's good. So that's some examples mostly. So this one you won't have to change much. It's basically explain to you that if you know a bit about Python, you know that Python objects have a wrapper, a dunder wrapper. So when you hear dunder in Python, it means a method with 2 underscore before and 2 underscore after. So you will hear dunder init, dunder equal, dunder wrapper, dunder stir. And so we extended that in IPython to say, well, and Jupyter, say, well, you don't need to be text only. You can be PNG, you can be SVG, you can be anything you want. And so I'm going to go slightly faster on this one. And so the equivalent of print, but for all the formats, is called display. So if you use IPython, either you can import it explicitly on a relatively recent version of IPython is already there. So if you call the display on an object, like a pandas data frame, it will show itself as HTML. And so that's just showcasing some of oh, that's wrong. That's okay. Anyways, where is it? question? It's not there. Well, a bug. I will fix that. So hopefully the output is still saved. So if you have an image and you do Shift Enter, it should show an image, or you can display it. You can also give it a URL, and it will get the URL and display it. Or you can use, this one is gone as well. I don't know why. So you can have rich things in line. When you have images, you can have either embedded, where you get the data of the image, or what's it called, not embedded or soft linked. So here there is not much differences, but here is the image of Lawrence Berkeley Lab Hall of Science. And you see that this one is the value of the image at the time I ran this notebook last time. So you see it was on April 28 at 12:13 p.m. local time in Berkeley. And if you look at this image, which is about the same code, except the way I've called it is slightly different, you see that it's actually just the image as it is now. So every time I will reload this notebook, this image is just soft link. It's basically just having an image tag. You can, of course, display HTML. I forgot to import it, starting to be tired. And so you can have your own custom object, or you can use a %% HTML magic if you want to just get some quick HTML. You can display LaTeX, and you can have your Maxwell equations. That's relatively useful. So that's just showing some of the things that that can be displayed on your laptop. You can run this one, and you will have some audio files. One of the funny ones was a couple of years ago. You've seen the LIGO detected two black holes that merged together. They actually computed, they shifted the frequency into the audible range, and you can actually listen to the two black holes colliding. And you can embed videos, like for example, having the heat equations on some system, or embed a different website if you want to have people interact with that. So of course that ties into the security issue that we talk about and why notebook get trusted or not, because you can actually execute things in the browser, and you should be careful about that. For JupyterLab, we extended this notion of rich output, and so now you can basically teach Jupyter and JupyterLab how to render specific file types, or more specifically MIME types. In some of the install instruction, you might have seen that we did install GeoJSON extension and FASTA extension. So GeoJSON is a way to represent landmarks using JSON, and FASTA is a biologic file format that shows some DNA. And what you can do is install extensions that both teach JupyterLab and the notebook how to render that in the browser. So here I have somewhere, if I can make that wide enough, I have a GeoJSON file. If you open with a normal editor, you will see that it's just JSON. But because I have taught JupyterLab how to render it, I can now view GeoJSON file directly in my browser, and if the internet connection is good, the tile should load, and now I see my I see directly this file as it's supposed to be shown. And same thing if you have a specific, if you know what a FASTA file is, you can have a specific renderer for this FASTA file. Let's look at the FASTA file. I want to have the raw view. So Zika assembly opening with editor. Let me try to get the two next to each other. And one of the nice things, or let's look, the first one is a dash here, the first one is a dash here. If I change, hopefully it should automatically update without having to save, so the two views are synchronized. But now that you've taught JupyterLab how to render a file, well, you can do the same in a notebook, and if hopefully this works now. You can have this fasta.ipynb, and now here is the complete code to display a FASTA file or a FASTA dataset without having it to actually be a file into the browser. So here I'm defining a FASTA class and say, well, now I want to teach IPython how to display it as non-text. Well, if I can only render text, just send the data as is. Otherwise, tell JupyterLab to render it using the FASTA viewer that we used for our file before. And that's it. You can actually make that in a py file. You can actually distribute it on PyPI if you want. And now, if you create an object like this one, like FASTA object equal FASTA, and now do FASTA object, it should display with my keyboard that just type 2 is. It should display properly. So now what you can do is you can write, with a bit of time, an extension for JupyterLab and say, well, I have this specific kind of data that I want to see in a specific way. Here is how to display them. Question in the back.
It's kind of similar to the representation HTML that used to be like wrapper HTML that would produce HTML output.
So is it similar to wrapper HTML that you have in classic notebook? Yes, it's similar in the sense that wrapper HTML you could actually do here. You can do you could do a text HTML, and then here compute HTML representation in the kernel. Self data. So you would actually send HTML to the front end, and the front end will say, okay, oh, here is our HTML. But here it's doing something slightly different in the sense that it's sending the data itself, and the front end is deciding how to render it. So the HTML here is computed by JupyterLab itself, not by the running process in the back. Which means that usually when you do wrapper HTML, that you've seen in the other notebook, the library author is in control of how the object will be displayed. While here, the library author just sends some data, and the users can decide which plugins they want to use for which rendering, which is a slight difference, but we're not going to dive too much into that. The big difference also from classic notebook is that when you register a plugin on JupyterLab, because you don't have to do a kernel computation, it will work with a file browser. While if you do wrapper HTML, you have to get a process in the back that does some computation. And that was not possible in normal notebook. Okay. Questions? Other questions?
How did you get to where you got the code to do the representation?
It should be root of the repository, notebook, and fasta.ipynb. And in fasta.ipynb, the only thing that does is create a dummy object that defines this. I'm going to remove that, or at least comment it, that defines this IPython display things and say, well, here is a MIME type, if you know what a MIME type is, and here is the data for this MIME type. The kernel will send all of that to the front end, and the front end will say, well, I know how to represent FASTA file. I'm going to use the FASTA representation. Or the GeoJSON. So let's try to do it with GeoJSON. If it already exists, this one. So from ipython.display import GeoJSON. Let's look at our GeoJSON object. JSON-able dict. So we probably want to do g equal, and what was the name of our file? The name of our file was data museum in DC. So let's do with open // data museum in DC as f. Let's try to just do that. f.read And let's try to do G. Will that work? Yep, that works. With a warning, not JSON string. And so now we are able to directly show some JSON. If we know our JSON is supposed to represent some geographic data, it doesn't need to be a file. If it was an API here, I could have done something like, as an example, but I don't know, request.get https://museums.org /dc/location.json. And that will be .content with requests and do geo.json of that. And if I had to do that, if this was an actual API that works, I would just like directly, instead of printing JSON, it would actually print the location of the museum. So how, and 5b is how to do that on your own. So that introduced some of the display HTML, which is slightly simpler, that Mike talked about. And it shows you, like, for example, if you have a custom class, which is a circle class, it's relatively simple, how would you create, how would you do that on your own? And so the way to do that is to create underscore REPR underscore PNG or HTML or whatever underscore methods that returns what the data for HTML or for LaTeX or for something else is. And so here is what you would return for HTML, what you would return for LaTeX or for JavaScript, for example. And one of the exercises here is to rewrite the my class circle to try to display a circle instead of printing some text, I am a circle. So we're going to take 5 minutes to do that, and then move on to the last part. Questions? Okay. So let's take 5 minutes. Thank you. It's 5b. 5b custom display logic. This still works?
I just saw it. It seems to, yeah.
Are we good? So if you're developing your own library, you can create your object and say, here is how to display yourself as HTML. So I've done it with REPL HTML, and you have the solution. Let's see how the solution differs. Well, print HTML, and also in LaTeX, or you can add several different methods like that, depending on like if you are going to convert your notebook to PDF, which is one of the possibilities, say how to represent yourself in LaTeX. And then you can force IPython to display as a specific, or Jupyter as a specific things. Here it hasn't defined for LaTeX, so let's redefine it, and now it will display with LaTeX. If you want to do something more complicated, what you can do is define how to do it in PNG using Matplotlib. So you can create a Matplotlib object. Yes.
So there must be a list of formats that are rich but ranked somewhere.
Yes. So there is a list. The question is like, well, which one do you choose when you have several? So yes, in the front end will decide, like you actually send everything and the front end will decide which one to display. It stores everything in the notebook document, which means that when you reload in either JupyterLab or another front end, the front end can after the fact decide which one to show. Also, for example, if you create a display JavaScript, it's going to be a high priority and it will display in JupyterLab. And if you convert to PDF, well, the PDF converter will say, no, I don't know how to deal with JavaScript. I don't know how to deal with HTML. Oh, here is a LaTeX one. I'm going to use the LaTeX one. But you can force, when you have display underscore PNG or display underscore HTML, you can force which one to send. Actually, what you can do is do display has two keyword arguments, exclude and include, I believe. I don't remember why it doesn't work. And you can say, well, I want you to send everything except image SVG, or I want to only send those one. That's slightly advanced thing, so we're not going to do that. So the other thing that here that exercise notebook show you is what if you don't control the object itself? What if you already have your circle object, you want it to be able to represent it as PNG, but you can't change the circle object itself anymore. What you can do is teach IPython here, and IPython, not Jupyter. Like say, no, don't use that to display the object as PNG or HTML. Use my own function that I want, because I know what I'm doing and I want to overwrite what the library author is doing. So here we have the function that converts our circle to PNG. And what we can do is get a handle on IPython itself and say, IPython, when you're requested to do some formatters for image PNG, so we're moving 2 steps. We're getting the things that converts, that try to loop to object and say, oh, how do I make things as PNG? And so the PNG formatter, when you see something which is a my circle, to generate the PNG, use this function. So now we have these functions that take a circle and return a figure object, which is a PNG. And now if we do that, because PNG is higher on the list you requested, well, now we have an actual circle which is displayed as PNG. And so the typical use case is what is just after, is what if you have NumPy arrays. NumPy arrays will usually have different meaning in your domain specific. You know that there are a map, or that there are actually matrices where you are interested in the numbers. What you can do is say, well, here is a function to convert a NumPy array to a PNG, or to HTML if you prefer HTML because you want to see the number. And now we're going to tell IPython when you see a NumPy array, so here the PNG formatter for type a NumPy ND array, use this function to generate a PNG for my NumPy array. NumPy doesn't have a default PNG representation because I think that it might not be the right thing. And so once you do that, now IPython say, well, if I see a NumPy array, when I display, or if it's the last statement of a cell, I'm going to generate a PNG for that and send it over. And so now, if I create a NumPy array which is just random n by n, well, I have these things. If I prefer to EMG, well, You could use matplotlib and change the color, you can change the size, you can do whatever you want, as long as you know how to go from a specific data to a given representation. And you can force to get back from NumPy, for example. NumPy has a pretty representation that adds ellipses, and so you can force to have a pretty text representation for these NumPy arrays if you want to skip the PNG representation. And so here is a nice gradient to finish that. And for the not even 15 minutes we have left, we're going to venture a tiny bit into cross-language integration. That you will have to go to specific libraries, but I want to show you that a lot of people think one notebook is one language, one kernel is one language. It's usually the case, but not always. What you can do is do cross-language integration. If you're doing statistics, you might want to mix and match R and Python. If you're doing some high performance, you might put some Python or some C inside. And there are many libraries that provide. We've seen the LP run line profiler IPython magic that you can load from a line profiler package. And here we're going to load some extension for RPy2 to move data back and forth between Python and R. So there is a lot of explanation, but I basically just created a Fibonacci sequence. So it goes from it grows. If I remember correctly from my university time, it should be exponential at some point or close to exponential. So let's just try to plot it. I'm assuming you kind of know how to use matplotlib, but we can dive into that at some point. And it does look like that. But the question is, how can we check that? Well, my thought is that if we do in a semi-log axis and do a linear regression, it should be close to a line, and we should be able to find the intercept at the origin and the slope, which would give us some information about the exponential growth. I actually am not quite sure how to do that in Python. Actually, I know how to do that in Python, but it's an example. So I'm going to use RPy2, which is a really nice package, which in itself has a lot of Python API to move things back and forth between Python and R. And it has specific integration with IPython. So again, I'm going to do rpy2.loadx or rpy2.ipython. And what this does is it injected in my namespace several percent or percent R something that can take non-Python code and do what should be done with it. And so the first thing it gives us is rpush, and what rpush does is it takes y, the value of our Fibonacci sequence, and x, the index of our Fibonacci sequence, and sends that to R. If the variable name are not valid R, it does its magic. I'm not quite sure I understand what that does. And now we have a persistent R session with x and y, which we can access from our Python notebook. And now every cell that we want to execute in the R process, we are going to proceed with %R, and it's going to be persisted on the R session. We still need to manage some of the movement, but some extension on other languages will do data movement automatically for you. If you write some R, that would make sense. You do a linear model of log of y versus x, so that hopefully should be a line if our value is long enough. We do summary statistics of that we put to value. We do plot x and log of y, which hopefully should look like a straight line, and look at our fits. And so one thing we will see here is that not only you can run computation, but the computation can send results and display rich objects. Like R knows how to plot something, and it displays it in the notebook, which is not a trivial thing to do. And indeed, our Fibonacci sequence seems to grow exponentially. We can look at the summary value. If you've done some R, this should mean some things to you. You should understand that better than me. But it tells you that it looks like, sorry, and the intercept is at -0.77, and the slope is that much with a standard error and a p-value. But now you want to do more from that, so you want to get the value out. You can just print them, or actually return them as an NumPy array. So %r, this is a line magic, so this returns a value. This is a cell magic, so this just prints a value. You can see this difference because here there is an output, and here there is no out number. And if you remember correctly from the previous notebooks at the beginning, if you have a line magic that returns a value, you can assign it. And so you should be able to do something in Python equal something in R. So let's look at that. Our coef variable does not exist, so we are going to assign it from R, and RPy2 is going to do the type conversion for us. And then we can basically do some Python unpacking and get the first two values into the intercept and the slope. And now we have our value back in Python. So we've mixed and matched Python. We created a function in Python. We did some statistical analysis in R, and we are back in Python for the analysis. R is nice for analysis, but it's not the fastest one, the fastest language around. Python is not either. Cython does work well. If you heard about Cython, it's like Python plus some type annotation, and it will compile to C, and hopefully you will get something fast. But using Cython can be quite challenging because you have to write your own module and so on and so forth. But the Cython developer were nice enough to write some integration with IPython so that you can just basically do things on the fly. So what you will do is the same as with R. You will load an extension from this module, so it's not shipped with IPython. You have to have Cython installed. And if you do %% then all of that is going to be compiled in C. So you see that it looks a lot like Python, except now you say that n is an integer, but it can be a Python integer. But inside the loop itself, x and y are going to be integer as well, but C integers. And now you have something that really looks like Python, but just compute your function way faster. And you just have to basically put %% Cython at the top, put some type annotation, and now you just define a function which is way faster than if it was in pure Python. And you can directly use it without having to import it or anything. And one of the nice things also is that you can redefine it on the fly. So here you see that it does 112, and let's change that. Let's put it to 6, which is not correct, but you see that you were able to redefine this function on the fly, which usually you cannot. Which means that now you can also have quick interactive workflow with a faster language than Python in some case. So let's go back to 2, and let's compute our two things here. And we see that, well, we got about a factor of 10 in speedup, slightly less, between our normal Fibonacci function and our Cython Fibonacci function. Here what I've done with the time it magic is to force it to do 3 loops of 100 each, just to have something, like to show you some extra example for the time it magic. And I think we have a couple of minutes for question, and if you want to play with that, and after it will be time for lunch. And there is one survey that they asked me to ask you to fill in, and so let me just write that here, and then we can wrap that up. And if you have any feedback, feel free to write on the sticky notes and stick them next to the door when you exit. And I will be happy to take that into account for the next tutorial. Questions? Tired? Coffee? Yes, question.
What do you recommend for version control in Jupyter notebooks?
So what do I recommend for version control of Jupyter notebook? I actually put them like that in Git and just push everything, even the output. It's not the best when you want to merge things. if you try to merge things, I would suggest to install some extension of Jupyter notebooks that stores them as plain text file. But if you do that, you lose the outputs. And one of the critical things in Jupyter notebook is because they store the output, you can send them to someone and they can see the output without having to rerun everything. Does that answer your question? And there is JupyText, something which is relatively recent that does some of that. YGT, 2T, ZG. Let me see if that works. Yeah, that works. And so yeah, if you have sometimes make it bigger. Yeah, like that.
Can I do multiple kernels on the same notebook?
Can you do multiple kernels on the same notebook? No, I don't think. I mean, there is technically no limitations, but I don't think there is any option to do that. And what would you want to do with several kernels? You want to move data back and forth between kernels?
No, but maybe I can run a cell with Python 2 and another cell with Python 3, and the third cell with bash.
So you want to run one cell with Python 2, one cell with Python 3, and one cell with bash. I would use cell magic. I would use, I would start a single kernel, and the single kernel can talk to several languages. Like, for example, if I want to, if I do Python 2 print hi, it works. So here I have a Python 3 notebook that ran Python 2. It did run Python 2 in a subprocess, though. Sorry.
But that would be the same way for Perl or Ruby.
That would be the same as Perl and Ruby. And so now the magic author can decide whether the process that it's talking to is persistent or not. So the %% Perl, the %% Ruby are non-persistent. Like as soon as the cell is end executing, it stops. But the R author decided that the process was going to be persistent and provided R push and R pull to get and push values. And so now, if you want to write a Python 2 magic, you can overwrite existing magic. And a Python 2 magic that knows how to serialize NumPy array, sends them to a Python 2 process, and does its things, it's possible.
So in other words, the kernel designation is always at the notebook level, not at the cell level.
The kernel is always at notebook level. Yes, one kernel can be at many notebooks. A kernel is just a remote process that gets user input and figure out how to execute it. And so there are some kernels that are made to be multi-languages. You tend to have one kernel equal one language, but for example, at work, I have a kernel which is on my local machine, but if I want to run something on the supercomputer, I just switch the kernel to actually be on the HPC system. Or I can have a kernel which is a different Conda environment, or I can have a kernel that have a limitation in memory or something like that. So kernel switching UI, sorry, it's zoomed in, so it's hard to manipulate, but here you can select kernels. And so, yeah, and you can, I could attach to an already existing, like for example, let's go to the FASTA one and select, and now this notebook, which is called, I don't remember what, if I do FASTA object, I will get my FASTA object from, because it's actually the same running kernel. And food is there in 2 minutes. If you want to be the first one to have food, feel free to run outside. And come and talk to us for the rest of the conference, and enjoy the rest of your conference.